All right. Happy Friday, everyone. We have a Free Energy Friday in collaboration with League of Extraordinary Inventors, Mike Faraday Research. We got special guests tonight on top of the regular crew of Lulu. Mike Does is coming, and we have Phil Bouchard with us. We have Michael Boyd back for the first time in about probably 8 months, I'd say. It's been a while. So looking forward to that. And returning from last week, Benefactor, who's been busy this week with updating, doing a lot of work on the Vortex coils, the PoE coil, and hopefully we get some good news and more over Unity. Is that what you do?
Yeah, exactly.
Yeah. So apparently it is putting out more energy. How much is debatable at this point? I do have an addition to the circuit I'd like to show everybody. We'll leave that for later. I'd like to let, like you said, everybody who has time constraints present first. And I'm really interested in actually seeing some of your presentations because I haven't really seen any presentations from anybody here.
Yeah. I just want to make a couple of announcements really quick before we get into the show. I just got word of tonight that inventor Paul Babcock has passed away, and he passed away on June 4th. And he was doing a lot of work with Jim Murray on the Dynaflux generator system. So that's kind of a big loss, kind of a bummer to hear that. But, that's the reality. A lot of these pioneer guys, they're starting to die off. They're getting into their later years now. We still got Eric Dollard. He's still alive. Jim Murray. Those are the two oldest inventors I know of right now that are still around. But unfortunately, test of time, people do pass on eventually. So it's us guys, the younger generation that's kind of has to step up to the plate and carry on the work and learn off those older guys that were doing this, for pretty much their whole life. And so, we should watch some of their old videos and try to get a grasp on, what they were actually trying to accomplish with their systems. Jim Murray and Paul Babcock, they were working hand in hand together, basically two different systems.
8 years, like 10 years at least or something since they
first. Yeah, I think it was around 2015, 2016 they met. And they realized the two different systems they had were basically the same thing, but just done in a different way. So they did a lot of collaboration together in those 10 years and were producing machines that had COP of 50 and above. So, so it's kind of a bummer to hear he passed away. He was one of my favorites, actually. I like to listen to Paul as a speaker, and he was very good at it. And he enjoyed it, and he enjoyed sharing a lot of great information to the public on how to make these systems and how to make them work. And it's just it's a great loss in my opinion. But we got to.
That is a devastating loss. Now, it took me a moment to realize who Paul Babcock is, and literally, it's like at least 3/4 of the videos that were Jim Murray in them over the last 5-6 years also had Paul Babcock in it.
Yeah.
And just the wealth of knowledge between the two. We'll have to definitely end the stream tonight with watching a little review of their work. And it's just that's devastating to hear.
Yeah. So as far as my battery stuff is going, I did some calculations. It turns out my little batteries I've been working on are putting out 4 kilowatts of power per month. And that's just continuous stream of power coming out. So,
kilowatts out of those batteries per month?
Yeah, per month. About a kilowatt a week. About a kilowatt a week it produces.
And you've had it running for at least 4 months straight now, was it?
Yeah, it's about 4 months now. Yeah. So I'm basically trying to back engineer what Michael Kantz from Quantum Magnetics was working on, and he's another one. He passed away in 2021. Some of his stuff was patent pending, and then he passed on. So there's another inventor that got lost in, due to, a shortened life, and his patents are nowhere to be seen. I can't find anything in the Google patents I know his son's still alive, but I don't know what's happening with it. Also, his YouTube channel is still running, but his store where you're able to buy his power plates or his quantum power cells, all that's been taken down. So there you go. So my job now is to try to back engineer what he was doing. And, I think I'm onto a really good path right now. I have somebody helping me out, so we're getting a lot of materials, carbon graphite, and all the materials we need. And I seem to have a pretty good mix. And actually, John Bedini, another one that's passed on, he passed away in 2016. He actually solved the problem that I've been trying to solve with my cell with the magnesium deteriorating. He found a substance that actually preserves it. So I've got that material now, and I'll be testing with that very soon. So instead of the magnesium deteriorating, by the end of the month everything would deteriorate. Now I can add maybe years to the life of the magnesium in my cell. So yeah, pretty encouraging. Yeah. So there's one of the videos, Paul Babcock and Jim Murray together. Paul's on the right. He's the one that passed away on June 4th. So yeah, you can maybe play a little clip of them talking together.
Sorry, yeah, my computer was frozen there. Yeah, absolutely. I'll unmute it here. But you said that you've just discovered something that will extend the magnesium's life for 4 years.
Yeah,
in a battery. Like in my electrolysis, magnesium is like one of the fastest to dissolve, like within
that's right
under an hour, sort of thing, right? As an anode. And that's huge. That's crazy.
Yeah. So I'm going to be doing testing with that material. Actually, it came from John Bedini. So if you watch the Energy from the Vacuum series, he talks about that. And I suggest everybody watch that video. So he talks about the crystal battery cell. So, apparently he was corresponding at that time with Laser Saber. And he told Laser Saber, yeah, I found this material. You should try it. And then after that, Laser Saber wouldn't correspond with him anymore. So I don't know if what the situation was on that one, but if somebody came up with an idea for him to go forward with it, I would definitely pick up and run with the ball, so to speak. Yes. But he didn't do that. So yeah. So that's pretty much
Paul Babcock. He was the guy who did the low carbon steel thing, right?
Yep.
Listen for a minute.
And that was the first thing we built, the last thing we patented, just because of circumstances. So it's sitting there right behind you. But it, we built the thing, and then it's just the same story as Jim's got. You're trying to raise money and show people, and just like talking to bricks.
Right.
So they were. It was beyond, at the time, it was beyond anybody's understanding. So investment people were dealing with, so well, what can you do with your switching besides this motor? So we weren't sure, so that was clear back in 2002, 2003. So we started hooking the thing up to regular, DC motors, AC motors, and putting other applications to the electronics. And we just found that we could just do amazing things with inductive devices. And that's where, so we decided we were going to patent our electronics first before we patented the motor. And that's a long, winding story of, we had a lot of great people we had to deal with, and we had a lot of shysters, people trying to beat us out of our intellectual, run off with our patent port. It's an incredible story. Someday I'm going to write a book about it. Tesla's lament was, well, the bankers and industrialists have taken my work and made this century theirs. But he goes, but I tell you, the next century will be mine. And that's what I'm about. This is going to be the real Tesla century. We've uncovered what he was telling us. And we've opened up a whole new world of science and application. And it's going to happen. It's happening now. And that's what I came to this world to do, is to advance humankind and to bring this stuff to fruition. And, it's just going to happen. And, I've given many a PhD in intellectual beating, and I'm not adverse to doing it some more if I have to. So that's how it goes, But I'm not taking any prisoners. We're not slowing down. We're not in a bag. It's just going to happen. And if we can engender public support and open minds, you know, people's minds have to open to the concept. They have to throw off the old conditioning, especially with electrical physics. And the more people that do that, it builds up more. It's logarithmic. It builds up more momentum. It opens people's eyes to the possibility. They start realizing it's a factual route, and then that will drive the process further.
And do you have any final comments or words of encouragement or suggestions for everybody out there that's going to be watching this interview?
Well, Paul and I were discussing something along those lines just yesterday, and I think it's important to relate the following. You know, the whole thing with people who do independent research has been for the longest time, keep your information to yourself, race down to the patent office at your earliest possibility and get everything squared away in your name, and then sit around totally paranoid while you're waiting for first office action. And the irony of all of that nonsense is that you actually play right into the hands of certain individuals who don't want any change. And while I'm still required to patent stuff for my own protection, and so is Paul, I think that the other lesson that we need to get from this is that intercooperation and opening your ideas to each other and sharing stuff in the long run is probably a lot more valuable than hoarding the information and hoping for the best. Because if you follow that route, you're going to get one incredible screwing. We'll leave it at that.
Well, thank you, gentlemen. This video will be online shortly.
All right, I'll pause it there. And I was reading the background there, the sign Burn Copper, Not Coal, Advanced Inductive Research and Development Corporation. We're going to have to reach out to them / Jim Murray and get him on, as well as Aaron Maxim. I can never pronounce his last name right. Murakami. There we go. Aaron
Murakami.
Murakami, yeah.
And that he's the one that's doing these interviews and put together the Energy Science Conference once a year. And yeah, good. Got to keep the memory alive and advance the work, right? Like, we can't let Paul Babcock down. We have to, reach out to Jim Murray, and we got to bring it forward. And I'm just stoked that he brought this up, Mike, even though it's a tragic loss to the community. Adding his name and his information, and everybody who's watching who's actually dedicated or interested into free energy, electrical engineering, and the technology and development of it, your homework is to go watch at least 6 hours of Jim Murray and Paul Babcock with Aaron Murakami as the interviewer. There's probably at least 50 hours minimum, probably thousands.
There's tons of stuff,
right?
Yeah,
But
tons of stuff.
Just get yourself a little bit acquainted. Jim Murray first got famous on YouTube when there was a movie made about him called The Modern Reproduction of Tesla's or something. Tesla technology. I forget the exact name. Anyways, he was able to utilize work out of the electromagnetic field over unity aspect of the electrical engineering. If I
wasn't he working on Lenz force and getting rid of it in the motor?
He defeated the Lenz law. Basically, is what it's done. It's a very similar switching technique that they do in their system that I do in my Renegade. Yeah, they're very common. It's a reactive power generator, and Jim Murray talks about that extensively about his system. It's reactive power. So,
and one of my
I'd like to say something about
videos on YouTube.
I got something to say about defeating Lenz law. It's very understandable thing to say. It's like, have a magnet; it pulls to the iron, right? There you go. Defeat Lenz law with that.
Yeah, it has to do with the switching, also the space between. If you're using an iron core in your coil, there has to be a
Right.
certain gap range. So you basically get it to the threshold where it starts to attract, but not pulling it in. So when it starts pulling it in, you know you've gone too close. So you got to just back off on it just a bit.
Right.
So now
right.
you're gonna rely on the magnetic field that's created in the coil to do the pushing, not attraction by the core. But it's the timing of the switching is also very important. So those two things, if you get it right, there is no Lenz law. So that's very
Well,
important.
no, the lens is still there, but
It's still there,
attraction,
but
the
there's a way
attraction
to
force. Copper has lens. You can't get away from
Right.
that.
right. But there's a way to engineer around it. Now, like Bedini back in the day, he was actually experimenting with hollow cores, actually using a steel tube instead of a solid. So that would,
Yeah. So he would get
Sorry,
some
I
pull,
just
but
had
not
a
too
thought.
much.
I have to interject and ask your guys' opinion of this. With Keshi's technology, would this be an engineering material way of affecting or getting around Lenz law with his nano-coating, where you're taking flame or electrolysis or caustic, breaking down the outer metal solid of it into the nano, and it defeats, or I guess it makes Ohm's law retarded or
It's hard
something.
to. Well, I
Modern electricians.
I got this one, Mike.
But
Bernie.
would that work, or is that something else?
To do that, you gotta remove the insulation on the magnet wire, and to have the inductor be a magnet wire, it has to have the insulation. So if the only way to do that is to wind the coil without the arms touching, and then burn it, and then pass the north-south magnet around by the arms.
I get the process of how to do it. I've made many of them, and having to separate insulators between each layer of wire, and it's not letting them connect, and getting the nano layering made between each. I was just saying, is that
it's possible
actual engineering aspect that would make sense as a possible meta material that could be used, or that they're using in their process, that actually could be averting this Lenz law or bypassing it?
Manufacturing a coil that's thick enough to pick up all the EMF from a magnet without the winds touching is not very easy, but yeah, it probably could be done, because you still need the nanocarbon on every layer of wire.
That's not what I'm asking. I'm just asking if you do it correctly, even though you're breaking down the metal, which is like the electrical, like you're degrading the solid wire, which supposedly degrades the actual electric current potential of the wire. But the reason you're doing that is that if you have an outside field force that's taking more of it, that it would be able to, what's the Lenz? How does the Lenz?
Well, copper has more breaking force on a magnet pass than aluminum does. Different metals have more breaking force on the magnet pass on a wheel. That's your Lenz effect. And that breaking force converts to amps. So it's like, if you do get rid of it, do you also get rid of the amps?
Yeah, that's why.
If you do find a way around it, if you find a way around it, do you allow the eddy currents to still flow through the copper without the Lenz happening by coating the exterior wire with nanocarbon? That is a possibility.
Sorry, Nathan, please continue. I'm thinking about
the magnet, the field from the magnet, it hits the copper wire, saturates it.
Can you hear me now?
Gerald, yes, sir.
Gotcha. Hey, everybody. So Bernie, think of Lenz law as an electric scooter. As you're racing down the road and you hit the brake, and it dumps that charge into your battery, but it slows you down at the same time. That's Lenz law. It's like electromagnetic braking, so to speak.
I get it. So every like revolution sort of thing, you have the Lenz law effect in the way, correct? In trying to get that electricity through or charge through.
Yeah.
When
I got
a
something to
north and
add.
south magnet passes the arms of a coil, it saturates the EMF onto the coil, right? And the coil is, capturing some of the force of the magnet, and therefore there has to be a transition or conversion of a break of some kind, because it's capturing that like a net,
Well, Mike, I can
the
add
net
to
is the
that.
break.
Mike, I can add to that. See, in my system, because I use a disruptive discharge, right? So what happens is when you make that disruptive discharge, the pole in the coil actually flips. And because of that, if you get the timing right, the Lenz effect basically disappears. You've actually counter-rotated the force of the magnet. Instead of pulling into the core, now it's going to repel it. So the second you do that disruptive discharge, the pole in the coil flips. And if you get it right, you'll defeat the Lenz law. And I've done it, and it's not that hard to do.
That's what Bedini did. That's how he got rid of the Lenz.
Exactly.
He put the high voltage 4007 diode in reverse polarity. So when the flyback happened, which creates the Lenz, by the way, I'm pretty sure it's
part of it, yes. But if you can flip that polarity at that second,
it does flip. It flips on its own.
That's the engineering aspect that's key to getting it to work.
Yeah.
And if you don't have that tuned, the device will never work. And then there's the other aspect.
Yeah, it's not like we're trying to re-engineer physics here. We're trying to engineer the engineering.
Yeah, by capturing the flip, you're getting rid of the Lenz. By dumping the flip of the polarity, you're channeling the Lenz into the battery, which is what Bedini did.
Exactly. It's all in the engineering. It's all in the engineering. It's not like we're trying to rewrite physics here. Some of those, like Lenz law and Hertz and all these different laws. We're not trying to change them.
It's possible the nanocarbon could capture the flyback all day long and channel it. And maybe that's what it's doing.
I'm just going to give you a quick demo of the caustic method of making this nano-coating, and I fully comprehend everything that all of you said, and this actually might be the material that you need for the rest of the circuit of the copper.
Why don't we do introductions for everybody before we get into each individual project that we have going on?
I'm Mike Does. I work on pulse motors. That's pretty much.
Michael Boyd, go for it.
You guys, Bernie, all I see is Bernie's.
Yeah, we're on the side there.
Okay.
Okay, so Bernie's demoing. I guess we'll do introductions after.
Yeah, no, that's fine. Let Bernie demo, and then we can do intro.
That's a catch coil, okay. Nanocarbon.
He's got his audio off, by the way.
Yeah, his audio's off.
You're muted, Bernie.
My bad. Sorry. Didn't realize I was muted. What I was showing there, though, the black copper is the 16 gauge that was sitting in the caustic liquid for about a year, which is breaking down the outer shells of the already triple solenoid wires that are wrapped in there. And then there was the smaller, I don't know what gauge it is. Oh, it was like a 0.4 or 0.3 gauge copper that was also sitting in there, like that's this size, but it has a plastic coating on it, so the caustic doesn't work because I didn't strip the little plastic coating off of it. And that's a key part of the nano coating process. Another way that you can do it is taking a blowtorch to the copper and You don't let it get all the way molten red. It's just before it gets to that state of red glowing when it turns
Hey,
into
Bernie.
like a shimmering rainbow to make it.
Bernie, have you tried this one before? Is heat up the copper and then dip it into a cold water of borax.
Yes, that it works for resetting it and setting it in a permanent thing. The only issue is that when you're making the final, I guess, like drawing or formation of this nano coating layer, you want to have a direct charge or like a voltmeter hooked up to it so that there's an electric current charge directing all of that nano layering as it solidifies and forms that shell into a one direction.
Yeah, well, that's what Bedini was saying with the borax. When you heat it up really hot, it will start going dark. And then when it goes dark, like black, that's when you dunk it into the borax. And then the borax, whatever it does, the special nano coating will allow you to have that, the one-way gate, basically a diode. So
yeah,
you might.
It always goes into that black state when it's nano coated. And what's really weird is that Keshi first said this like 10 years ago, and I was like, yeah, right. And then now I've literally reproduced the effect happening like 100 times out of 100 times, where the entire wire, even under plastic coating, the entire wire after about 6 months to a year will be the black nano coated self-organized by itself, doing it into that state. And you can literally take a knife and cut off your plastic coating and find, instead of a copper color, the black nano coating across your entire wire. It's just weird and interesting. Has anybody ever gotten a mass spectromesis analysis of the black state?
All the spectroscopy analyzer. Yeah, I gotta get. I know it's hard, a tongue twister to say that. Yeah, I like to get my hands on one of those. That'd be
quadrupole mass spectrometer.
Yeah,
there we go.
Yeah, I used to operate one of those puppies.
My boss has a spectrometer that can measure the quantity of oxygen inside the brain through your skull and everything, and it's real time. It's pretty cool.
I want one.
All right, sorry, I'm gonna shut up now. Everybody, please do introduce yourself, and I'm gonna run around for a minute to try to find an example of a wire that I can strip and show the black nano coating under the plastic.
All right, Gerald, you're first.
Please, Bernie, no stripping. Sorry.
Gerald, you're first. Introduce yourself.
Sure.
Hello, everyone. I'm Gerald. I'm the guy with electromagnetic coils without moving parts. I'm in the process of getting a spot for APEC for a demonstration. So I'm gonna do a demo tonight for you guys, but just a small one. I'd have to set up the camera. My background is I'm a backyard mechanic. I'm an inventor. I do all kinds of different things. I've built alternator generators. I've built magnet generators. I've built, every free energy device on YouTube. I built it and pretty much debunked it as well. But great. After all that spending of money and gathering garbage from different parts of the city in order to build half that stuff, I mean, it's a hobby, right? So what do you do? But
exactly.
Thankfully, I've come across something that should be shared. You guys want to give me a sec here? I got to set up my camera.
Well, let's go through everybody here first, and then that'll give you time to set up, and then we'll come right back to you. Nathan, maybe you can.
My name is Nathan Bunton. I do Gravity Flyer. I run the channel Old Man Builds on YouTube. And I also do static electricity experiments. Basically, I could take these static electricity things, I can polarize it, and I can create force in one direction as a capacitor. So normally you get ion wind. I remove the ion wind. I take the paper part and I make it polarized towards the one side, towards the anode, and it'll force it in one direction. You can make it spin. It's a little bit like T.T. Brown. I don't know that I got anywhere close to the level he did, but I'm generating force. So the next thing in the experiment, I've already taken 2 flyback DCs and put them together, and they make this thing lift. Now, I could also do it with the Wilmhurst. I could do it with any kind of static electricity device. And the next part is I'm going to thin them down. So right now they're about this wide. I can show you. This right here is what's in the center of them. So you can see that right there.
Yep.
It's kind of thick. And then all you have is this right here, a piece of PVC. You got this big side and a little side. And the little side always goes towards the big side. So when you put them all together, basically what it's going to do is it's going to create a capacitor. Now, it removes all the charge out of it for ionized wind. All that's gone. You won't get any reading on it. What you will get is force in one direction every time. So if we can thin this and stack the plates until this thing no longer creates a force and then back it off one, then I can create a higher amount of pressure in one direction. And that's the next step. So we go right into how much is in there. And I can tell you right now, it's quite a bit. I expect to get a lot more than normally you would out of anything. So my goal is if I can get anywhere close to a half a pound by the time I add maybe 4 more of these when they're thinner. And the whole thing is the reason I think I can get more is I'm going to take the radius of this thing, because that's where the pressure is in this. You take the radius, you thin this portion because you don't really need it. You just need the mass amount of charge here, and it'll push in one direction. So by stacking them, you're able to get more force. So that's the static electricity one I do. I also do the gravity flyer.
Right. So you're building like a stacked battery, but as a giant capacitor thing.
Well, not necessarily a battery. It's meant to create force. So, I mean, there's no the charges in it. When I say the charge, it just means that I'm polarizing it. So I'm just allowing it to stick to something very hard. So, and when it sticks to it, I can create the force in it. So I'm not trying to create any kind of battery out of it to like make energy.
Sorry, I more meant that like the voltaic battery piles is like just like the geometry of what you're doing with.
Oh, could be, yeah.
It's the flyback driver that charges it. The high voltage negative.
It has to be 2 of them, so you eliminate most of the amps. You're in milliamps, and the high voltage itself is what's creating it. It's creating a charge on the actual paper way more than it would on a whole lot of styrofoam or anything else. It probably has like twice the effect on paper than it ever would on styrofoam. You could see it very clearly as soon as you hit the button. It's done. It immediately hits. So,
you know, that's funny you said paper, old man builds, because I can't remember where, but I heard or somewhere I learned that there's more lift on these type of devices when you do it over wood, and paper is made out of wood.
Yeah,
it's just
and
like
it's also high in carbon. It's it's a high source of carbon. Wood. So
wood polarizes faster than most materials ever will. So basically, anytime. I'm sorry, what?
Most of the planet is wood, so these devices would have no trouble getting around over a carbon-laden planet if it's got to do with carbon anyway.
Yeah.
Because the paper's carbon, The paper's carbon.
I just know that when I started doing like the high voltage, that anytime you take a piece of aluminum foil, you put it on the table, you hook your fly back up to it, it'll immediately suck down. It'll also be the reason why your paper lifter or whatever you want to build doesn't lift. So your ionized lifter and stuff immediately sucks down because it immediately repulls everything in the whole thing to immediately suck down. Get it to break that, you have to keep it off of it, or you have to reverse the charge quickly in order to bounce it off. So
Interesting.
Right.
yeah, that's kind of, I have to do the same thing in the gravity flyer. In order to get anything to stop polarizing to the ground or the table or anything, you're going to have to reverse the charge quickly, or else it's not going anywhere. It'll actually go from a
That's
vibrational
why you're not
state
getting it
to
to
a-
lift. It keeps polarizing to something else.
Yeah, it's
It's
pulling
on the ground.
down. Now, the way to get around that is you have to bounce it off, but you also have to have your Tesla coil in ground, earth ground. You have to
Yeah.
have it there.
Yeah.
In order to be able to reverse the field quickly, it has to be able to respond that quickly. And because of that thing's tied into your Tesla coil, that's the way it does it. So it actually takes the top 4 inches of your Tesla coil. When you have the wire down on the throat, you're not having it directly connected. It's down the throat. When you do that, the top 4 inches takes on the exact frequency of this center plate right here. So every frequency that comes in it from this disc, that disc, the piezoelectric disc in the top up here, everything comes into it. And you have to find the right amplification in it in order to get it to even run right. And then when you do, you actually get rewarded. So what'll start happening is originally it starts to shake like this. And then when you get the amplification of energy because you hit the right resonance pattern in here, you can amplify this disc to this disc, and you'll actually take the Tesla coil energy and the high voltage energy, and they'll amplify together. So it's like this disc right here in energy is swelling, and it's creating pressure on both of the other discs. And it creates like a capacitor, and it takes the capacitance in that capacitor and drives it up and creates an amount of pressure in there that you can actually flip the field based on when the piezo buzzer hits. So it's a whole interesting concept. There's probably maybe 40 interactions in this thing that you have to know before you can get anywhere to get anything to give you an amount of energy more than what you would normally put into something. So it's pretty hard. It's not just one of those things you just plug into the wall and say, hey, we're done, man.
Yeah.
I wish it was.
Cool. That's awesome. Okay, so we're going to go to the next person to do their little intro. I guess we'll go. Yeah, we'll go
Put
to
Mr. Boyd on spot
All right.
because Gerald
All right.
needs to resend him the link. So we'll do that,
All right.
and then we'll go to Ben, and
Yep.
and then Phil.
All right. So,
Okay.
Mr. Michael, sure, you're the on the floor now, Mr. Mike.
Okay.
You are
So,
spotlighted, sir.
I'm Michael Boyd. I'm a physicist, engineer, and an archaeologist too. And I've since, I don't know, started in 1998 when I was working at this company that made disk drive test equipment. And I fabricated these little, took a hard disk platen and I made 3 of them where I put little square nano bumps and nanopits on a surface of a hard disk along a radius. I did that with a thing called a focused ion beam, which is a fancy electron microscope. And then when I was doing this to make for an optical tester thing that looked for defects on the discs in the manufacturing process, and I took this disc and I put it on this thing called a certifier, which measures the magnetic properties of the hard disk ladder, and discovered what's called gravitomagnetism or nanogravity. And I discovered that there's 2 kinds of nanogravity. There's a pull type of gravity, and it's produced by the presence of mass moving, the little nanobumps. And then there's anti-gravity that's produced by the absence of matter, or little nanopits, as they moved under the sensor. So what it is essentially the same thing as a semiconductor diode, but for gravity. And
Really?
Didn't discover it. I
That's so
discovered it,
fascinating.
and I wrote a paper back in 1999. It was published in the International Society for Optical Engineering. I wrote a paper on it. And then in 2012, I was reading this paper by this guy, Hal Puthoff. I don't know if you know him. And Hal Puthoff was talking about space-time metric engineering. And simplified, what it has to do with is as you get closer to a massive object, say you decide to spend a little time on the surface of the sun, well, time goes really slow there compared to here on Earth. And but although the time goes slow,
So the bigger the mass, the slower the time. So that's why like things like insects are like so quick and fast, but have such short.
But the opposite is true for space, empty space. You see, we focused all along on the mass part, but we forgot the empty part. Okay, and so basically, as you go into space, time goes faster. Right, but length gets longer as you go towards mass. Time gets longer, but the length gets shorter. Okay, and that's basically what Puthoff's paper was about. And the other things that happen is you go to this what I call expanded space-time. You get blue shifted as you go towards the denser or the more massive space-time. Well, everything gets red-shifted. So now with that in mind, if you think about the whole universe is supposedly expanding, and how do they figure that out? Well, it's based on what they call redshift. Okay, well, what if that's gravitational? What if they're wrong and the whole thing isn't expanding? What if it's all forever? Is what I'm saying.
I think you said, Michael, about
but the point is this. I took this, and then just last July, I submitted a paper to the IEEE Sensors Journal, and they just approved. Last Friday they accepted my paper. Okay, and basically what I'm doing is I'm solving string theory, because the problem with string theories is 11-dimensional. So that means you got to have 11-dimensional tensors. I can't do that math, can you? So my solution is I made little nanobumps that are less than the Planck mass. Follow? So I'm measuring, and I'm measuring it at 100 nanometers away. Okay, so I'm all within the so-called Planck domain.
Right.
Okay?
Yeah.
So, and that's where I found this nanogravity. And
it's on the gravity's on that nano scale. That's
so now
fascinating aspect.
The reason I'm going to preface what I'm working on, though, is I have a test here. This thing, it's called a differential time meter. And what it is it has the timer here, and then the sensor, and then a 100-foot cable. Okay, and so what you're able to do is say you take the meter upstairs, and then you take the sensor downstairs. You should see a time differential. Follow?
Right.
You're getting closer to the Earth, so the gravitational field should be stronger. And then vice versa. If I turn it around this way, it'll be the opposite effect. So I should be able to measure whether the gravitational field is stronger or weaker. And so my reason for doing that is I live in Santa Cruz County, and we have this gravitational anomaly called the mystery spot, where they already know there's a gravitational anomaly there. So what I want to do is map it out. see if we can. So basically,
Is that one of the spots where like the cars literally roll up the hill?
Well, the ball rolls uphill is what it looks like. But what it is there's a whole book on these that show they're all over planet Earth, these gravitational anomalies. The point is that another way. So what this does is it has crystal oscillators. Okay, now the other way you can do it is with the tuning fork. So the frequency of the tuning fork changes as you go into increased gravitational field or decreased gravitational field. You follow? So it's a physical phenomena that it's reality. It exists. It's just that we've taken it for granted. And if there is free energy, that's where the free energy is, in gravity. So now, for example, one of my little nano bumps, a nano bump that's a 20 micron square and 32 nanometers tall, produced 32 milliwatts of power. Now, if you scaled that up to like 1 meter squared, it's like 40 megawatts. So
right,
now the problem is scaling it up, of course. And when you're talking, I don't believe it's free because you got to spin the disc, right?
For sure, but like you're showing and proving that there's a fundamental difference between what they're trying to project gravity as and what it actually is, and that in reality it's existing on this nano physical geometry scale in the Coulomb area, just
gravity.
like everything else.
Well, I think what's going on, dude.
That's what quantum is. It means it's real tiny.
So what you're saying that the gravitomagnetism creates a energy potential that is actually the gravity, nano gravity. That's very similar to what I'm saying. It's in fact what I'm gonna tell in my little presentation. But we're very close together.
Bill, that's why I think everything happens for a reason. I don't believe in coincidence. Okay. There are no outliers. I'm an experimental physicist. There are no outliers. Everything happens for a reason. And you talking to me about 10 days ago, that happened for a reason. You know?
Yeah. We're like we understand each other. Like we've known each other for a long time.
Yeah. Well, maybe we did. We're in the same time stream.
It's similar.
So that's basically my spiel, I guess, guys.
So now Nathan is going to have to take the nanogravity aspect onto the gravel flyer, and maybe, that might.
Well, actually, the gravel flyer does use the nano. In fact, that, what is it? The center disc, I noticed that it has some kind of weird film on it. It's got nano features on it, doesn't it? And it has something to do with the frequency of there's ultrasonic source involved in it too, correct?
Yeah, we're using harmonics and also the octave of it. And we're trying to hit right around the 5th octave in it. When you hit it, it amplifies all the power in it.
So gravity, most people think gravity and electromagnetism are the same thing. They're not at all. Gravity can be slower and faster than the speed of light. The speed of light is the same everywhere, no matter what the frame of reference, okay? That's because photons are timeless and spaceless. They don't experience time or space, okay? They're virtual, is the way I like to describe it. But gravity is an inertial energy, so it's time dependent. That's why when you talk about frame dragging in general relativity, it's because gravity is time dependent. Electromagnetism isn't, okay? And then anti-gravity, which is produced by the absence of matter moving, is time dependent in the same time frame as gravity is. So there's basically two space-time continuums, one for gravitation and one for electromagnetism. Okay, and that's what. So like it's kind of like in the magnet, when in the electromagnet, when you're switching polarity from the magnetic field from one to the other, you create what's called hysteresis. Okay, where it's kind of like an S-shaped pattern in current versus voltage, and there's a delay. There's a time difference between the two. That's the closest thing I could find
You're talking
in
about
electromagnetism and what's going on with gravitation. So
there's a delay, right, between the amps and the magnetic field.
right. So, and what I
I
actually
can't remember which is ahead of the magnetic.
Mike, you're staticky here. Sorry.
Yeah, I can't understand it.
It's cool.
Staticky? Still?
Yeah, not now. We're saying something and we couldn't understand you.
Is it the current that lags the magnetic field, or the magnetic field that lags the current?
It's the magnetic field that lags the current.
It's behind the current, right?
Yeah.
Right, that makes sense because it's current.
Reluctance. It's reluctant.
You're supposed to resistance in the material is generating the magnetic field through the pushback of some kind.
So inertial energies, though, just totally different. Now, the other thing that was interesting, so in a hard drive, you have these little magnetic domains, or they're bits that you have a little electromagnet, it makes these little nano bits on it of positive and negative magnetic field directions. And then the little magnetoresistor sensor reads back those bits, and that's your digital data that you get off your disk, okay, your disk drive. Now, some of them are rather large because they have your data, what's called a data zone where your data is, and then they have these other zones called a servo zone, which is like a big off-on pattern, and that's for alignment, essentially. It's an alignment pattern in a certain zone of the disk that references your data, okay? And that's basically, but a nano bump or a nano pit will wiggle the little sensor arm, okay? But those data bits, electromagnetic data bits, don't wiggle it, okay? So there's no physical force being imposed by the electromagnetic field.
And those nanobumps are created by the photon.
But the bump or the pit will actually produce, the pit will produce a push force that I could measure with a little piezoelectric sensor on the head, it's called, the head arm. And then with the GMR or the MR sensor, I could measure, quantify how strong the force was using magnetic force measurement. You follow?
I just had an idea, Mr. Boyd, and everything that you are talking about and working on with the nanopacket gravity, have you applied it to the Victor Grebenikov nanostructuring, I guess, materials and experiments?
So are you talking about metamaterials,
like the bug wings?
Oh,
and
the bug wing. Yeah, I've looked at the bug wing thing. It's a nano cavity.
Yeah.
Okay.
Yeah.
That's on the surface of the wings. Okay, that's creating a cavitation effect. Which, yeah, that's exactly what the nano pits do. Okay, is they produce a push force. So, and as I was saying with the Graviflyer, on the disc in the middle, the surface of the disc in the middle, there should be there. What I'm suggesting is there's some sort of metamaterial structure, and if you don't have it, this book here.
Ooh, I need that book. Or you got a Return from Metamaterial Monday episode with that book.
It's a pricey book. It's like a couple $100. I bought it used for like $89 before anyone knew about it, right? But
so you're gonna slowly scan pages and come back every fourth Monday for Metamaterial Monday episode.
The point is, you can look at this now when you're talking about doing what is it, ultrasonics and high frequency electromagnetism. What this does is you can engineer the surface you need to achieve the harmonics you're seeking, is I guess what I'm trying to suggest.
Yeah, that's why he uses the upper plates textured, and so is the lower one.
Right.
Basically, he's creating the beetle shell part, and instead of getting a resonance chamber with the beetle shell, he's getting an open resonance, and we're losing energy because of it.
Right.
And it amplifies, but it's not as good as it could be. If we just had a shell around it, then it would be a lot better, because it's like an open air magnetron. So if we close it in, we can pull in the energy better.
Right, but what this does is the problem is your source is uncollimated. It's the best way for me to put it. It's not. It's kind of like too noisy for you to. If you could create this meta surfaces, I think you could achieve the harmonics you need to get the thing to lift.
So you're saying I just need a clearer tone.
And don't connect to ground either, like your supply.
No, this is so everything in the universe is moving with respect to everything else. When they talk about rest mass, there is no such thing as a rest mass. Okay, nothing's at rest.
Yeah, it doesn't connect to ground. The Tesla coil connects to the ground.
I think you should try to run everything without connecting to ground.
Yeah, it doesn't work.
No,
well,
you don't pick up the energy. There's an energy doubling going on.
Your source has to be grounded, or else you're not going to have a source. Okay.
Well, you can send one Tesla coil to another one to lower potential, move it that way.
So, but I'm just making suggestions. From my personal experience is that there's everything he did it. I mean, you can see his videos and you can see that he did it, that it's the real deal, but it's got to be falsifiable. It's got to be reproducible, or else.
He's probably not disclosing everything. Maybe he soaked the discs in, some type of acid to, create the little holes.
No, honestly, by working with it, it's how you tune it. If you can't do it right, you won't hit it. It'll look like it does nothing. That's why I tell you about the energy, because when you pick it up, it doubles. So when you got your high voltage coming in, and you got your Tesla coil energy, you'll get a little sparking on the brushes, right? If you back off the high voltage almost all the way and you turn up your Tesla coil, now, when the energy hits, it's going to over amplify. So it'll go and hit everything. So if you have any metal that shouldn't be there, it's going to spark right over to it. It'll look like you turned your high voltage to double.
That might explain why people's cars go out when they see craft go overhead or whatever. These craft, their power goes out.
The center plate is cold, but the outside is blazing hot. So there's something. There's another effect going on there. Yeah, it's. But you can measure 74 degrees.
Endothermic in the center, and then extremely hot on the outside.
Yeah, it's hitting all the outsides. As soon as you hit that special state, there you go. It's burning. It'll burn your finger immediately. But you put the meter on at 74 degrees. So you're kind of at a loss, like I'm burning my hands here and I don't get it. So there has to be something else going on. It's taking that resonance, creating energy.
Do you see an indication of heat, or you just feel it? Because you could just be feeling weird electricity and thinking it's heat.
No, I burned my finger right on it and showed it right to the camera.
It burned your finger, actually burned your finger. Okay.
Yeah. It'll put a degree burn right on your finger. No problem whatsoever, quickly. And then, like I said, it's cold. So you're looking at it on your little meter and you're going, well, why is this thermostat thing, why is it showing that 74 degrees and my finger's burning?
It is weird.
I mean? So it's an anomaly, but you have to hit special states in it. You have to be able to harmonically tune this. Like I say, it has to be like a singer in the right tune, right? And you have to keep tapping the center plate until you get that right tune. And then once you do, immediately the energy picks up. I mean, like immediately, it just starts going higher.
How do you control the ultrasonic frequency?
Basically, I turn it on and I wait for to hear it popping. It'll make clicks. As soon as it's in the right resonance frequency where the energy is going to amplify, you'll start hearing it making clicks. And as soon as it does that, you're going to start to hear your Tesla coil back up with energy, because now it's forcing it back into the Tesla coil, not just out of the Tesla coil, because it's down the throat of it. It's not connected directly. So it'll have a crossover and it'll start to really build up power in your Tesla coil. That's why the ground's important, so that it can shoot it back in. As soon as you need it to flip
use a battery or something else.
So there are ultrasonic, tunable ultrasonic transducers that you can buy.
I didn't know that.
So I suggest you Google it.
Do some homework.
Because that's what you really want to do, is you want to have one that's tunable, and then you want to be able to hook it up to your spectrum analyzer.
Yeah, I use barium titanate in my system, and it's fully tunable.
So that's what you need to look for, because basically you got to look at, because that's what you said it. It's how you tune the thing, right?
Yeah.
Assuming you get every component assembled correctly and the correct geometry and everything, you have the correct power, and you've got all that from the inventor. It comes down to tuning, and so but my understanding is
it is an instrument.
Gravity is actually a phonon. It's a type of phonon. Okay, and I learned about this back in the 90s when I was making semiconductors, where they had these lattice defects that move. The little crystal, they move in the crystal, okay, and they're phonons. Phonons travel through the crystal lattice. If they do that, why should they be able to do that in other mediums?
That would explain the heat.
What's a phonon exactly?
Phonon.
It's not a photon.
So that's
though,
like it's like
It's like a
photon that is light, but it's a sound one. It's a sound version of a
is a
photon.
timeless, massless, lengthless quasi-particle. Phonon is a massless, time-dependent quasi-particle. It's time-dependent.
So one's light particle, the other's a time particle.
It's an anti-gravity, what they call anti-de Sitter space.
Isn't a particle have mass though?
Well, it does. It's got positive mass, not negative mass. Doesn't weigh more. It weighs
how is it?
less.
How is it massless then? How is it massless? You said it was massless.
It doesn't come from mass. It comes from emptiness.
Its energy has
Some
mass.
people call it the quantum vacuum or the 0 point. They got all kinds of different names for what they call it, but it's not the Casimir effect if you need metal plates, okay, to produce the Casimir force. You don't need metal plates. this gravitomagnetism field, I measured it on little glass nanobumps. They made glass substrates for hard disk patents, but they didn't put any metal on it. And I put one of those on the spin stands, and I could measure the gravitomagnetism signals coming off glass nanobumps. Okay, so it's not. They call
It's just the dimensions and that's it.
Would it be similar to, say, quantum tunneling?
Quantum tunneling is an example of gravitational interaction faster than the speed of light.
There you go.
Okay. And you get quantum tunneling. An example of quantum tunneling in nature is coronal mass ejection on the sun. So what happens is before you have a solar flare. If the solar flare heads towards Earth, it's an electromagnetic pulse. It hits the Earth, takes approximately 7 minutes to reach the Earth at the speed of light. The coronal mass ejection, a bunch of the corona is thrown off into space in a big wave, like in the ocean, millions of miles wide, and it takes 3 days to get here. Well, the thing they discovered is that a day and a half before the flare, the radioactive decay rate in certain radioisotopes on the dark side of the Earth changes. It slows down. Okay.
Yeah, it gets weaker.
And so what happened? What's going on is there's a pre-signal from the anti-gravity pre-signal from the sun. It's one of these.
I guess it would be kind of similar to, say, like a tsunami wave. Before a tsunami hits shore, the water by the shore actually recedes back out to sea.
Exactly.
So
there's a pre-signal, okay, that comes before it, and I found this same effect with my little nanopins. There was a gravitational signal before the electromagnetic pulse produced by
that pre-signal is not an outward signal; it's an inward. It's going the other way, away from Earth. It's pulling. That's why it's pulling. It's pulling on time. It's pulling on time. It's dragging down time. Pulling time down. The coronal mass ejection is going outwards, but this thing is happening before the outward thing.
Yeah, no, this is happening before the electromagnetic pulse from the flare.
That's right. It could be an inward effect happening before the outward effect. Is what I'm saying.
Or is it's like a charge?
Well, the point is, the question was, is it a tunneling?
It's pulling from the backside of the sun.
That's what tunneling is. Okay.
Before it explodes.
And I learned about quantum tunneling in the late 80s. We made these. So basically, when in a semiconductor junction, you have 3 different charge exchange mechanisms. Like silicon diodes use what's called diffusion limited, which means that all the semiconductor material is involved in the charge exchange. Okay, and then there's this, as you cool it down, you get what's called generation recombination, where the junction has a little like bubble where there's like a positive charge region and a negative charge region, and that's called generation recombination exchange. And then as you get really cold, like below 50 degrees Kelvin, you get what's called tunneling mechanism. And what tunneling mechanism is essentially, the simplest diode is a piece of metal on a semiconductor. It's called a Schottky diode. And what's going on is the electrons are actually tunneling.
in no certain direction, huh?
And then so what it looks like is, when you look at the diode curve, it's usually like and then it has a forward bias and a reverse bias region. And what happens is it goes in a loop on the positive side, where it actually at one point the electrons are identically but of the opposite spin on the two sides. And that's when that's
So there's
called
like a neutralization happening of some kind?
Yeah. So it's like the space-time is being shifted over a little bit into the future. Is the
More like
best way,
paused. More like it's being paused.
right? Well, I
Or
mean, if you think
suspended
about
animation.
what, how does have you ever looked at gain in a like amplifier gain? What's going on there?
Yeah, you don't go too high, you get distortion.
Right, you get saturation is what you get. So, but if you get in this, there's like a sweet spot region where you get like gain, like 100x or 200 times the gain in the signal. Okay, in your amplifier.
You mean the feedback?
Right, exactly. It's you're creating a bubble is the best way to describe it.
Yeah, it does get louder, the feedback. It just keeps getting louder and louder and louder. And it's like, what? I'm not turning the volume up.
And then it goes when you get the saturation. It just hisses. It just makes.
Right. So, the gain is. I guess that's a resonant effect. It's the circuit's just finding resonance and it's reaching its maximum.
It is. It's a self-resonant
capacity. Making.
It's a self-resonant effect, is what it's actually going. So, and that's what you're trying to achieve with the gravifier. A self-resonant.
In that Tesla coil, exactly, right there.
So,
exact effect I need.
But you can't. Yeah, right. It's
well, you got to.
It's like trying to.
It's
like trying to tune something you can't hear.
You got to be able to repeat it. Is the problem?
Excellent. Gerald, are you there? I don't know if he's there. Maybe we'll go to Ben.
Benefactor.
How you doing?
Maybe you want to get us up to
Can you
speed
hear
on
me?
what you're doing. And yep,
I hear you.
you're just fine.
Yeah. So I've been following in the footsteps of Daniel and Erica Nunez of First Stop Energies. And when I stumbled upon their work, I was astounded and captivated and kind of obsessed trying to find out, is this real? And I spent months just trying to determine how possible this is and if they were telling the truth. And I came to the conclusion there was a 90% chance they were. And so I spent better part of the last year trying to replicate some of their experiments with the rodent coil design they came up with, the PoE coil. And we've been getting really positive results. And it's really interesting. As you can see, this is kind of what it looks like. This isn't a usable one, just a visual demonstration. So in my research, just going over it real quick, because I don't want to take up too much time right now. I'll go over it more extensively later. But in my research, I found that there's a few mistakes that people make with the rodent coil design they came up with. And one of them is you have to have multiple windings. The second one is you have to have this interference pattern. You have to have the clockwise and counterclockwise. And then the third one is the most common mistake is you have to have tightly bundled wires. Your winds have to be tightly bundled together, because if they're spaced together or spaced apart, the magnetic fields aren't compressing on top of each other. They're not amplifying their power. So
exactly, Bob Grenier states goes through this in depth with the same effects with winding the bagel coils as well, and it's to get the unification in the symmetric field force generated throughout the solenoids.
Right, exactly. So that's pretty much what I've been doing, and we've been getting some over unity results. I'm not sure like how accurate my multimeters are. They're pretty good, but it's open to interpretation how much we're getting out, but it is obvious we're getting more out. Yeah, it's obvious we're getting more out than in, and I actually added, in addition to the setup, where I mimicked the output circuit with the exact same components. So we see how it reacts at the same time on the input side without the coil hooked up through the output of the stereo channel B. So it's a surround sound system. So you have channel A hooked up to the coil, left and right, and then channel B hooked up to the output circuit as a demonstration. So you can actually visually see.
Winding?
No. It's just a mimicking circuit, so you can see the input and the output at the same time with the same exact components. So you can see the input is, say,
your oscilloscope channels. Sorry, you're talking about your two channels on the oscilloscope channels, right? Channel A and B.
I mean, if I had an oscilloscope, no. I'm talking about my
your
fan.
stereo channels.
The fan and the LEDs. The fan and the LEDs. So you can see the fan spinning.
Are you able to just quickly take your camera over to?
Yeah, I can show you real quick.
For sure, why not? Let's take a look at what you're talking. Visuals always help, and that is real science, showing the real experiments and tunings and tinkerings. And once you get a system, it's like you just change one little thing each time. Measure the difference. Oh, you're muted, Ben.
The PoE coil, is it two coils or one coil? Is it two windings or two windings?
Technically, it's two coils because it's two channels. They're not.
So there's four ends. There's four ends.
Right. So as you can see, there's one input channel and one output channel. Channel A is red and black, and channel B is yellow and green, but they're not connected in series. So we have 12 wires, each channel connected in series.
Parallel. Oh, geez.
No, in series.
12 wires. 12 wires. 12 individual strands connected in series.
Exactly, but each channel. So 24. I go over this in the. If you look at my recent upload, there's a guide in the description that has a link in the video where Erica Nunez goes over this in more detail, but.
Right.
It's this specific design has 12 wires per channel, and each channel is not connected. So channel A here is the input, and channel B, the yellow and the green, is the output. And it's just going to an output circuit with a little fan and 3 LEDs.
Or four pairs or two pairs?
2 pairs.
2 pairs of 6. Gotcha. All right. So that's 4 ends. 4 ends.
No. We have 4 leads total.
4 leads, right. 2 pairs of 6. 2 pairs is 4.
Right. So, but the
that's
important
two
thing
inputs.
is,
2 inputs. Gotcha.
Right. But because you can have as many channels as you want, honestly. As long as you have 2 channels.
You can have 1 channel.
That's
2.
Right. Well, you can have 1 channel too, but it supposedly it's not going to produce the same effects or some of the same effects. But who knows? 3 channels could, I think, produce some unique effects if you have 2 positive and 1 negative. 2 the same and 1 phase shifted. So, but the addition to my setup here, you have the fan and the 3 LEDs. With the rectifier and the capacitor. So it splits off AC, DC, so you can see how it's reacting to with both on a load. And then I mimic that on the input side. So it's the exact same components. So you can see on the input how much power is coming out visually. So I'll give you a demonstration of that.
How much power is going in, you mean?
Right, exactly. And this is not hooked up to the coil. This is just hooked up to channel B on the stereo output. So this is not hooked up to this.
Yeah. Schematics are very helpful. They really do. I got to check out that link with the schematic.
It's just a simple rectifier circuit, but the connections and how to hook up and wind the coil is the most important part. And that's all in the guide. Yeah. So
I mean,
that'll give
you're
you
sending power into one pair and drawing off the other.
Exactly. It's an inductance of some kind.
All right, it's like a primary and a secondary. Yeah.
Right, exactly, but a 1-to-1 ratio. If I have it right, but who knows? It might not. It might be asymmetrical. Some of it. I don't know.
Yeah, it's 1-to-1.
That's awesome either way.
Exactly. Like the results are kind of undeniable. You can see the input power and the output power. Same exact fans, 3 to 6 volt powered fans. This fan is barely spinning while this one's going like max RPM.
Oh, keep in mind when you're charging the primary to draw off the secondary, in the center of that coil, you can also rotate the shaft with a magnet and generate power as well at the same time.
Oh, really? I thought you just had to do the low end frequency.
That's the whole point.
Right. So
that's the whole point of this type of coil. If I were to
to drive a magnetic motor, but I thought you could only do that at the low end. I haven't really experimented with the magnetic motor yet.
You send power into the primary, load the secondary as you have it now, and you have and that if you get the magnet right inside the center to spin, it'll spin while you're you're loading the secondary. So
you see how fast it'll spin that neodymium sphere, and when you look at the input voltage, it's extremely low.
Right. It's low voltage.
But also I have a new multimeter. It's the same one, but it's a little bit higher rated. It's 600 milliamp rated. It's got a brand new fuse. It's working now, so we can read the current on the input and output as well. So I can demonstrate to you.
Definitely key pieces of equipment needed.
Right, exactly. That was kind of devastating when I blew the fuse. But I'm kind of new to this. I'm still learning.
I mean, Ben, if you put a shaft right on top of that coil over the center with a magnet north and south over it, it will spin while you're loading the secondary. And then you can tie that shaft to another alternator, and
Yeah, multimeters can be very sensitive sometimes, depending on the brand, depending on different brands. So it's you gotta be aware of that.
I've blown up many multimeters. Trust me, I learned the hard way.
But you're doing good for experimentation if you say you don't do that often, because it's not that easy.
Yeah, no, I'm trying to monitor it now and trying not to overload the system. I got it calculated so it can't go above 27 on the gain, or else it will blow the fuse if I'm reading it on the output. Even with the new meter, it's 600. Like it goes above 600 milliamp from the output. But
that's your bench power supply doing that, though. It's like those real sensitive fuse on them.
You come again?
Those bench power supplies, they have a real sensitive fuse on them. It wouldn't be, like a real car battery. It'd be better for you than have to deal with that fuse going off all the time. Although, keep you from burning out transistors and things like that. Having that.
I'm not actually operating off of the workbench power supply. I'm operating off the stereo amp. And that's just
what's powering you're powering it with a stereo amp. I thought you were using
the stereo amp kind of is kind of like a cool hack for somebody who doesn't have expensive
the stereo amp. The fuse on the stereo amp is going out, or
no, the fuse on the multimeter. But it's just a cheap hack that you can input a tone and output a small amount of power at the same time.
And then can you also alternate just the acoustic tone going through and going in?
Yeah. So any kind of input. So right now I have a phone app hooked up to the stereo, but I just got a cable for my laptop that I can also, experiment with as well. So you can, input different tones, and not only that, like music and maybe multiple frequencies and see what happens.
Yeah, That is exactly what I need to do as my next step into my electrolysis experiments, into the anodes and cathodes, and I've been wanting to start doing that for a while.
Maybe Bernie, we're going to get to Gerald because I know Gerald usually has to ship out soon. So Gerald, if you want to show your stuff there that you had your coil from last week.
Can you hear me now?
Yep, the floor is yours.
Loud and clear, brother.
Floor is mine. I'm going to be rich. Just kidding. Okay, so what I have here is the coil you seen last week, except I now have 12 pickup coils on the outside, and each one of them has a red LED, but not all of them, the LEDs, not all of them are hooked up to the DC. Some of them are hooked up to the AC side. There's 3 here. One's hooked up to the AC side, one's hooked up to the DC side. Technically, they all shouldn't light, but let's see, right? So what I got going in here is 12 volts through the primary. It's a 2.5 volt or 2.5 amp, 12 volt wall plug. This is the watt meter. The frequency is 33,000 hertz square wave with, let's see, the duty cycle is 6%. So I'm going to just turn it on to show you that I'm pushing the charge outside of the coil itself, and I'm going to pick it up with all these coils here. And I don't know if you can see that because I'm not sure if my camera can pick it up. Can you see all the lights on?
Sorry.
Yeah, I can see it.
Yeah, we can see them.
And this here is an LED cube that I've got partially on, and that's running on the back EMF. But if you look at the wattage, I'm using 0.01 of an amp to run all those LEDs. And this here, this one panel takes 94 volts to light and 1 amp. But yet I'm lighting that, half of that, all these. Oh, and this here takes 3.5 volts to light. Not a big deal. But let's put this in and turn it on. Of course, the wire fell off.
Well, there it goes.
So it's just another pickup coil from the center, but as I put that in, you would think that I would draw more, but it hasn't changed. So I just wanted to point that out. I'm not going to get too in depth as to how this is working. I'm doing a presentation on APEC, and I will get way in depth as to how it works, what I've done, and the type of thing it takes, I believe, to get a whole lot more power out than this. When I'm showing you now, it's a pittance. I will be turning on a 900 watt heating element, as well as levitating a magnet in the center here stably.
That'd be cool.
At APEC. So this is just a little bit of me. I just wanted to show you that I'm pushing charge outside of the coil. And in fact, I can push it right to the edge of my room, 10 feet, 15 feet, give or take. But it's something that we'll get into in depth in the future. So thanks for your time, guys. This is me.
Yeah, that's really cool. Yeah, I think you're creating almost like a plasma field. You're exciting all the electrons in the space in the room because you're running at such a high frequency. Where you know, like a plasma ball, it's using plasma to create that exciting of the electrons or the energy in the free space around the device. So I think you're doing the same thing, but just in a different method.
Ionizing the air and then using the geometry to implode at a micro level, right?
And it's not wired conventionally. Like I said before, I'm running a negative bias circuit. I'm running a NPN in order to do this. The other, I've tried a PNP. It doesn't seem to work quite the same way. So maybe, I guess I could put it like this. There's a bunch of instabilities that electrical engineers purposefully go out of their way to cancel out in circuits and in devices. Those instabilities are what I've used to make this work. And like I said, I'll get into, the depths of it, like the dichotron instability, the proximity effect, parasitic capacitance. It all comes into play. This wouldn't work with just one thing. It needs them all. There's 7 different instabilities that go into making this work. So just a short little,
Have you experimented?
tidbit. It's me, I guess you'd say.
Have you experimented on putting a different organic object in the field, the frequency field, and see if they get, like, for example, if you put a plant, would it grow faster in that energy field?
Yes, it does.
It's interesting because Daniel and Erica Nunes had the same effect with their magnetic experiments.
Right, where they were actually to the point of growing celery in the dark, and it like sprouting always to the center of the coils, even when they were like feet away from it.
Yeah,
well, I've said it in previous lives. This will actually, when you ground it out and the ground is wound within the soil of the plant, you're going to increase your output of that plant by double and cut its time in half to maybe 1/3 of its original time of growth. I've seen it. I've done it many times. I've got notes on it. It's just something that I need to prove on video. The problem is it takes a long time because you're looking over a month of growth period rather than, 3 months. You're still looking at a month, but it's
4 times as many grow cycles in a year. Like, that's 4 times as much food for everyone. No one needs to starve with this technology.
Basically. And this isn't the only one that's out there that can do this. There's many different devices out there that can do that very same fact. This just happens to be one of them. Is it a big boast? Sure it is. But I can prove it, and I will in the future. I just have to figure out how to do it on film or on camera over that period of time. Maybe
just a heads up that there's already videos out there with magnets and plants that are fast forward. So
they're using the South Pole field in order to grow food exponentially. And that's funny you say that, because I can split the field where this is the south and the bottom is the north, or I can flip a switch and the bottom would be south and the top is north. It really doesn't make a difference. This coil's kind of there's a lot of anomalies that I'd like to go over with somebody who's serious about pulling it apart and seeing how it all works when it's said and done.
Right, because I've watched your little demo. Your videos are very short, but they're showing extremely anomalous effects. Just proof of demos for those that understand what's on your channel and what you've been doing. And absolutely, Gerald, we need to do Year of the Coil, experimenting on these different effects, because it's also
Bernie, it's funny you bring that up.
Most practical applications, I believe.
Well, it's a means to an end. All those little tidbits that you see on my channel are all leading up to the APEC presentation, where I'll unveil a lot of the different anomalies and things that I've seen this do. And then maybe we can get some peer review going on and take it from there. So, yeah.
Will you maybe throw what?
And while you guys got me on the limelight, I got to say, Nathan, amazing work. I've followed everything you've done, watched every video. Dude, you're almost there. I'm telling you. Me and you should talk about something off screen that I think might help you, but that's a whole other story. Amazing work. Just had to say that.
That'd be really cool. Thank you.
All right, I'm gonna get off screen here. Thanks for your time, guys.
Yeah, excellent.
Yeah, thank
Right
you
on.
for your presentation.
Looks like we got
Phil,
Tim on.
before you fall asleep, and we're sorry for, and Tim will be right back. He said, but yes, Phil, please do give us your piece. Sorry for making you wait so long, brother.
Yeah, so as everybody knows, I'm gonna show again for people who I never presented my experiments before. I'm just gonna show them again. Sorry for those who already saw them like 2 or 3 times, but it's very important. And it's about anti-gravity, and I'm gonna end the little presentation with nuclear energy. But it's kind of I hesitate to show the equations, but I'm gonna show the graph. So here we go. Window. Entire screen. There you go. All right. So I'm just gonna. Can you see my screen?
Yes, sir.
Yeah. So this is my paper I started writing 14 years ago. I'm not gonna go in details about it, but I can say that it's basically I'm explaining everything, the whole universe, based on time dilation and gravity and time dilation, and I'm saying the energy potential induces gravity and time dilation and temperature. So the energy can be any form of gravito-electromagnetic or electromagnetic or a combination like light beam. I'm gonna show also experiments to prove that what I'm saying is right. It's already tested, so it's not professional testing, but I mean it's a start. It's a home do it yourself home experiments, and basically here just the big picture. Here there's a absolute gravitomagnetic permeability, a relative one as well. People forget about that. That's around this value. For those who know, I know my Dr. Boyd is gone, but he would have understand that very easily. But the relative gravitomagnetic permeability, that's what allows us to harness to generate an energy potential artificially, and we don't need astronomical amount of energy to do so, and we can harness it with home experiment. So that's what I'm saying. There's a relative gravitomagnetic permeability as well, and energy density limit. That's so. Also, I'm explaining the perihelion precession disparity, the light bending, the galactic rotation curve. Here I'm showing the momentum of accelerated particle. I'm saying if you consider light to have an equivalent energy, then you can get the same result as special relativity for the momentum and everything like that. So you don't need you don't need Einstein's special relativity to explain the momentum of light and things like that. So you can do so by considering light has an equivalent mass, and here the energy of accelerated particle, and the one thing I want to show. I don't want to go through the galactic rotation curve is pretty cool as well. The galactic rotation curve is right here. I'm able to explain 500 galaxies using my formula, which is very simple. It's this equation right here. It's you mix time dilation with the Newtonian Newtonian orbit of planets, and you add a spinning framework. So it's very simple, it's very elegant, and you can explain 500 all the galaxy rotation curves. And last but not least, whoops, it's 3.2, huh? Yeah, 3.2. The speed of light is not constant, and I took the time to write it down in my updated paper. They did an experiment with the supernova GRB 090510 that exploded 7.3 billion years ago. They found a discrepancy of the speed of light of 2 seconds, and if I use the Shell-Mayer equation that is used to calculate the diffraction of light in solids and prisms, I use that equation on using the air medium or vacuum, which is very close, very similar, and I calculate the difference between a light beam of high frequency and low frequency. Then of that distance of 7.3 billion light years away, I measure 12 seconds difference. They observe 2 seconds difference, so it's very close. And so yeah, then again, the speed of light is not constant. And here I'm going to show the experiment to prove what I'm saying is right. These experiments are again for those who saw them already, but this is an interferometer here that shows I'm moving a magnet next to the laser, and you can see the laser being deflected by the magnet. So that basically shows that the energy density of the magnetic field affects the trajectory of light. And I have another experiment here to prove it, which is light itself.
Light with magnet.
Yeah, this is a Cavendish experiment done by Fell Forward Research, and yeah, so you can see the rod is attracted by light, even when light is still hot and is still emitting infrared lights. The energy density creates an acceleration, a force or an acceleration. So that's what gravity is. There's just an energy potential. And here my magnetohydrodynamics vortex of liquid gallium that I already showed multiple times, but I want to show it again to those who haven't seen it.
I need some gallium for electrolysis. A little liquid gallium, a little liquid mercury at some point.
Yeah, I can show you the store. I bought it. I think it was from Seattle, but I don't remember. But it's pretty cheap, and I have 2 liters of gallium. But gallium is safer than mercury, but mercury is less resistant to electric current, so it's more convenient for experiments. But if you drop it on, I dropped gallium all over my apartment, and it was a mess to clean up. So I can't imagine with mercury, But yeah, so again, I'm gonna show it. You can see the balance on the right is shifting when I get the current going on, and when the gallium is at solid state, there's no shifting. So that means the gallium is not moving, and it's not inducing a shift. So that was the experiment part. And last but not least, the electric force, the atomic force here. I wanted to I integrated my theory at the atomic scale, and here the x-axis is the distance from the center of an atom. the y-axis is the force in Newton. The positive y-axis is the repulsive force, and the negative y-axis is the attractive force. So you can see that if you have an electron coming towards an atom using Newtonian or finite theory, it's going to get attracted up to a certain level. And then the lowest peak, the red line, the lowest peak of the red line is the weak force, the weak atomic force. And the peak, the leftmost peak of the red line is the strong force, the strong nuclear force, which is a repulsive force. So the electron, when it gets too close to a proton, is going to get repelled. And I can explain it with my theory as well. And I'm not going to show the equations because I don't think it's a good idea, because the parameters can be changed and we can change the reactions here, and we can harness this type of energy, which is a nuclear energy. And I think there's going to be it's kind of some sort of nuclear reaction, an easy way to create a nuclear reaction. So that's.
Would you consider this a low energy nuclear reaction?
No, it's
Not
as
a low
powerful
energy.
as you can imagine. You can use any atom as well, any type of atom. Then you don't need a radioactive atom at all. So I'm not gonna get into the details, but I'm just saying that it's possible. So yeah, so that's what I want to share, and it's some form of type of 0 point energy here.
That's cool.
Your red laser light with the magnet, that space in between, would that be like a
C'est bon.
superposition quantum, like particles or space?
Yeah, it's a beam of light that was deflected, so it's very small. It's a very accurate. I use an interferometer because it's very sensitive, and yeah. So I'm showing that just using a neodymium magnet is enough to deflect the laser beam at that scale.
I would recommend another experiment, seeing if there's a difference between a blue laser beam and a red laser beam with the magnets.
Yeah, good idea. That I heard green laser beams are dangerous though, so I'm not gonna get into those. But blue is I can try that. I still have my equipment here. Thanks.
Thank you, Phil.
So yeah, that's a form of energy. So if you don't hear about me in the next 2 weeks, then you know why.
We know the Five Eyes
We hope
gotcha.
that doesn't
And
happen.
You drank too much red wine.
Yeah, I'm
Fell
gonna
off a
present
cliff.
the Five Eyes in the June 25th.
You tripped on a rock. I don't know.
We got together. We remain. We are strong together. Like as long as we open source as much as we can. I know you have to keep certain components hidden because of safety concerns and all that. But
we don't want a mushroom party.
Right, exactly. But
Don't fall
generally
asleep at the
keeping,
patent office.
generally keeping the science open source is key. You know, if you like in my condition,
absolutely.
Yeah, just
I
open
just
source
open
it, man.
sourced everything day one.
Yeah,
As soon as
that's
they
why
start promoting.
that's why I wanted to be recorded. So if something happens to me, then
Yeah, we know you made a mushroom party, and
We've got your
Open
last
source it,
proof
don't
of life.
FOMO. Don't
We'll see you
FOMO,
back
open
here in a
source it.
few weeks for another proof of life, hopefully.
You can always live stream it at the same time. Call it, like media.
Please do live stream your meeting with
Yeah,
the Five Eyes.
Phil's
so we can all
Phil's
see you
mushroom
on-
party.
You're gonna see me somewhere in Vegas, you know.
Only there's like this giant shaft in this elevator going down, and then all of a sudden Phil's surrounded by giant moving humanoid mushrooms or something.
No, but seriously, there was a guy in APEC. He's some Russian guy, and he's linked with the Russian Defense Department. So that's why I said, all right, I'm gonna stop sharing everything that type of information. So
Yeah,
put
that might be a good idea.
Yeah,
give some people too many ideas.
Exactly. So yeah, man. So enjoy the show. Enjoy the show.
Yeah, I think we haven't heard from Tim. Did Tim drop off or?
Yeah, I guess he had to go.
Yeah, well, we've gone 2 hours. I don't know if
we
anybody wants to end anything. You know,
Ben,
any
were you
last
gonna give a little
words
more
or?
Mike does always have something interesting to say at the end.
And something loaded. Mr. Mikey Dad. Uh-oh. If you're on headphones or something like that, maybe disconnect it, Mike, or your audio jack. We can't hear you.
You hear me?
Oh, there we go. Yes, now. No.
Okay. No?
Yeah, for like the first seconds, just don't move whatsoever. Stay exactly where you are.
That's the Bluetooth, huh? Can you hear me now?
Yeah. Don't move your head because it's the speaker wire.
My head's full of salt. Controlling it with a double throw relay, so the poles on the coil flips every time you switch. You get positive here and a negative on this end of the.
Yeah, your audio is all scrambled.
Oh no! How about now? No. Get out of here! Go, stop it!
Probably Phil's doing nuclear experiments in the background, throwing off his
Oh
headphones.
my god!
Hold on.
You got GoFundMe just for his mic, man. That's bad.
I don't know. That's the Bluetooth. Can you hear it or what? I don't know. Seems to be working. Can you hear me?
Yeah.
Can you hear me now? Yes? Okay. So, and then the next time around, instead of a positive here, it'll be a negative, and then the positive will be on the other end. And the 4 poles coming out of the core here, this is the core right here, this part, will flip also. You know, you'll have a north on the first time around and a south on the first time around, and then the second time around you'll have a south and a north, and the same thing will happen on this end. And but if you look here, this is the drive portion where the magnets that are on the rotor, it's a north and south alignment. That's when this is where the south lines up over here, and the north rotor magnet lines up over here, and you have a north rotor magnet lining up over here. And you know, when you energize the coil, you'll have the associated poles generated in the cores, right? To then push all these poles at the same time. And when it moves 45 degrees, the 2 magnet poles, north and south, land over the arms of the coil. If you have a coil around the rotor, a stator pickup coil. And when the north, you guys can hear me, right? Just checking.
We can hear you.
Okay. So when the north lands over the arm of this coil here, it gets rectified through this diode here to the positive. And the south goes out the other end here through the other coil, because you have a south here also.
Would you say that you're shaping the magnetic field to be compressed in the center? Is that what it looks like?
Well, when you pass the north and the south over the arms of a coil, you get alternating current. AC.
Right.
So you have to rectify it to DC into a battery. And the north is coming out the diode that's facing the positive, and the south is going in the diode that's facing away from the negative. So it's dually rectified here. You have two rectification paths because the next pass is here.
It's just based on the diagram. It looks like you're manipulating the geometry of the fields, and that it seems like a pattern.
You see how you got a north here now,
right?
And the next pass is a south. You see, it's a south now. It's as it rotates. This is a rotor with 4 magnets on it, facing outward on the circumference of the rotor. And you have coils around the circumference of the rotor where the arms are, facing the two poles, 90 degrees.
So how are you timing the circuit?
Here's the drive portion. If you could faintly see the stator coil here. It's been opacity removed it just so that you can see the drive magnet hitting the drive coil at that time when it's positioned there. So this is where it's being driven, right? And power's not being collected in the stator right now until you drive it towards the stator, which is right here. Let me get this right. So it's here to here. So the north magnet is right now here. You're driving it to the clockwise to the stator arm. You see? Okay, and that's all done with the double pole, double throw relay. You have a plus and a minus on one pulse, and the second pulse is a minus and a plus. And you need to do that to get this system to work, because if you look at where the north is now, now it's a south. You see? Or better yet, let me rephrase it this way. If you look where the south is now, and it turns, now you have a north there. You see? So you need to invert the drive coil each 90 degrees. Every 90 degrees, you need to you flip the polarity of the coil. The double pole, double throw relay does that for you. And then when it hits the stator arms right here, I did that right, hold on. Right there, and the north lands over the stator arm, south lands over the other arm. Then it's going to rectify, out this way. The north is going to go this way, and the south is going to go the other way, with the other south to here. This north is going to go this way. In case you're wondering, that's what I think is going on. But anyway, you need dual rectification because of the way the north and south flips over the arms of the coil. So you can do that just simply like here. You see it here. That's no problem, in my opinion, to do it that way. That's just I'm a labless technician right now, so I jot all my stuff in a photo editor.
We understand.
Well, how much loss do you have in your system?
Well, here's the thing I wanted to throw at you guys. You see the magnet, right? This is iron. Okay. So this magnet when it's in this position over the floor, of course it's being driven and pushed. All 4 of the magnets are, because you got this coil in series. So when it's pulsed, it's running all four poles of the cores. So when it's here, the core material is locked onto the magnet, right? You have to break that connection with the pulse and you press it to the right. When you do that, and it ends up in this position at right here, in the middle. And the magnet is facing this iron right here. Right? So you might have some drag like that, So what I was thinking is, instead of having the core shaped like this, it's not exactly a circle shape. So you can make it more of a circle. That way, when this magnet is here, and it's being pushed along, it's going to break connection to the core very smoothly. And then as it gets to this point, past this point, and starts to head here, this magnet will start pulling to this steel stronger and stronger, like the V-gauge system. And it'll aid in this motor's locomotion, through full force to this core material, as well as the core on this part of the core heading this way. So yeah, that's just a change I'm going to make to this core dimension on this thing.
And you have no capacity.
But I've already gotten the double pole, double throw to work, so I know it works. It does drive a motor perfectly by flipping the polarity of the coil, and you can keep pushing these magnets as they're changing polarity over the cores, the rotor magnets. I'll go back here. Look, you see there. So now you got a north over that portion of this coil, and same thing here. And as soon as it turns, you have a south right here, south now. It keeps changing every 90 degrees. So you have to flip the polarity on your drive coil in order to flip the polarity on all four of these poles. Keep driving this thing along, and
So
having cores. Go ahead. Sorry.
Yeah, in essence, you're basically created an AC motor using a DC circuit.
The AC
You're
generator.
Yeah, because you're flipping poles from side to side, creating
it's
that.
An AC
that
rotation. It's a DC pulse motor.
A pulse DC.
It's acting like an AC pulse DC.
Right.
It's a inverted DC. I don't know. Each pulse is inverted, so it's an inverted DC pulse motor. Is the best way I can describe it.
Yeah.
It's not your standard,
So you're
plus and minus every time.
So you're gonna try to build this, right?
Oh yeah, that's my next stop. Yeah, so you could rotate a north-south magnet on the shaft. You don't have to use this setup, but with a double pole, double throw. See, I think Newman, when he was pulsing his motor, he didn't have a core, right?
Yeah, he didn't need a core.
But unless he was flipping the polarity of his drive coil, he had to let it have let it free spun for 180 degrees.
Yeah, well, he had a mechanical stator though, right?
Maybe he made a commutator to flip the polarity.
Yeah, well, that's what he did. He had a mechanical.
Well, that's totally awesome. I hope he did that. I don't know.
That's how he was. Yeah, that's how he's getting his effects. He was a mechanical.
That's the best way, in my opinion, because you don't lose. You're not letting it free spin on 180 degrees. It's doing nothing. It's actually what it's doing. If you have a core, it's slowing down. That's why he didn't have a core. He had no.
Yeah, exactly. Like if you look at one of his last videos of the big Eureka, he called it, you could see the actual commutator that he was using, and you'll see a little.
I want to show one last thing, Mike, real quick. I'll bring it up.
Yep.
He also used the weight, but he also used the weight of his system in the spin, like it complemented.
The inertia buildup. Yep.
I still don't understand how do you divert from the loss of energy to heat in your coils and not have a capacitor in the system? I understand the rotation. It's the loss that you're not accounting for is what I'm concerned about.
Yeah, you got to be able to channel that back EMF that's generated in the cores
But
and
the coil
capture
itself
that.
is going to heat up.
If you pulse it correctly, with a, say, like I use a disruptive discharge switch, it's high speed. My coil actually never ever heats up, and I
Okay.
could put quite a load on it. It's the actual make and break, that physical break, is what gives you the cold electricity, for one. Number two, there's no hysteresis that takes place in the core, so you get best of both worlds with it, and that's how
awesome.
Newman's motor worked. Yeah,
That's awesome.
and that's how my Renegade device works too, on the same principle. And another great effect is when you're doing a disruptive discharge like that, it doesn't allow the ion flow from plate to plate inside the battery. So what you get is a current-free potential. And I'm able to run my Renegade device on dead batteries. So
Pretty impressive.
Here,
Oh yeah.
I wanted to point out, guys, before you guys continue, you see how the blue magnet, the north magnet, is passing over the right arm of all the coils. It's always the blue magnet. And there's only one pair of magnets passing over one coil. The orange circles is the coil. There's only one pair of magnets passing over one coil at a time. And every time you see that, you're going to see that the blue magnet is on the right arm and the red is on the left arm. Do you see that?
Yeah.
Yeah.
Right.
Sorry, I got it wrong. The blue is on the left arm and the red is on the right arm.
But it's slightly lopsided.
That's the video editing I messed up there. But you see how the blue magnet lands over on the left, on all the left arms of the coils?
Yeah. Yeah.
One at a time. That's the three pulses, the three phase, right? We see the previous circuit I just showed you. It doesn't do that. The blue lands over the left arm, and then the blue lands over the right arm each pass. That's why you need the dual rectification. This is a standard three-phase generator, so you only need to rectify one way, one diode. You see? I just wanted to point that out. That's the difference between, they're both AC generators, but
Yeah, it'd be interesting.
different.
It'd be interesting to see how that shows up on the scope. If there's a slight
I was
phase
thinking
shift.
about that, Mike. Yeah, well, how would that
Yeah.
look? You know?
Yeah, how it's going to look, and if there's a slight phase shift or what do you call, power factor change.
Either way, I know just looking at it, if you have it rectified in both directions, there's no reason why it wouldn't dump into the battery.
The energy exchange would be the opposite of the rotation where the round magnets are, or the coils, the round coils. Sorry,
those three coils are tied together in series, so there's only two ends at the end of it.
Yeah.
Two wires. So only one coil is receiving over the arms of that coil a north and south pass, and each time the north is going over the same arm. It's not going over a different arm as in my design.
Yeah, the only thing I'm kind of worried about that setup is if it gets energized and you got the two opposite poles going over the same coil.
Look at it closer, Mike. I'm already worried about that. Look closer.
Yeah,
I know where you're going.
The cogging,
rectifier, right?
Well,
It's
no, the cogging. Well, it could have some cogging.
No cogging because you're rectifying in both ways. That's what I'm telling you. I've already thought about that. You're going to have cogging if you don't rectify in both directions, because you're not going to dump any power in one pass that's inverted. You're just going to let it fill up the coils and break your system. But I have it dually rectified for that reason. I have it rectified in both directions.
Yeah. Yeah, you'll have to build that configuration. I'd love to see how the waveform is on that.
I didn't think about that dual rectification thing until I drew it out. I didn't even see that one coming. Actually,
Yeah.
I did notice.
I have a question on the
noticed.
coil winding. When you wind it to the right or left, you get a north or a south. Did you take that into account on this?
Old man, I got to tell you, the double pole, double throw relay flips the polarity of the coil. No matter which direction it's wound, it's still flipping the polarity of the coil. The north is going to the other side.
So it bypasses
I don't know how to
that
answer that.
altogether. Yeah,
Huh?
okay. I'm just asking.
I mean, I've seen it over and over again. You do it with a car battery. You flip the wires around. You see your north is on the other end now. How is the right hand rule? It's not taking effect. I'm not seeing it happening. The right hand rule. I mean, you're supposed to get the north always on the side that your thumb is pointing. Your right thumb. That's the rule. But you wind it that way and flip the polarity of that coil wound that way, and your north is going to go to the other side when you give it the reverse charge from your battery. It's just you can see it in plain sight.
Yep.
It's a
good.
weird one.
Yeah.
Maybe there's something to that rule I'm missing.
Well, definitely a really good show today.
An anomaly.
It must mean that rule must apply that you're giving the plus on one end and minus on the other, something like that. And you're not flipping the terminals on your coil.
Yep, very cool. Well, Bernie, I think we've gone over 2 hours tonight. I think we'll call it quits. I think our panel's getting tired. It's getting late.
Yeah, a couple last things we got. Yeah, go, Gerald.
Hey, before you call it quits, I got a question for you. Did you see my Thane Hein replica video?
No.
Can you post the link?
No.
Can we load it up?
I'll put it out this afternoon.
Well, let's load it and watch
Did you want me to show it?
Yeah. Let's see that.
Okay, so what? I gotta just hit.
I didn't get that notification, and I'm billed to your channel.
Yeah, I'm subscribed with both
Really?
my channels.
I told you this before. I'm not, and I even signed up to your new channel that you created. I'm not getting notified to that one either. This afternoon.
Yeah, I don't know why that happens that way.
Ultra shadow bands evidence again.
So, yeah, they love
Can you guys
shadow
leave a link in the
banning me.
description for his channel? Because I'd like to subscribe to it.
You got shadow ban again?
Yes, please.
I'm always shadow banned. Are you kidding?
I know,
I was
probably all
watching
shadow
on
banned.
my.
Even me.
I was watching my notifications on my emails saying how people are subscribing to me, but my numbers aren't going up. And then I'm watching my video views literally in real time go down. It's crazy. I laugh.
I've got
Whatever.
pictures with timestamps, like literally hundreds, if not thousands, of pictures, screenshots of all of
me
that.
too.
Now it's
like you got a lead anchor on your leg.
Hey, I guess when you're over the target, they don't like you. I don't know. I don't know what to say on that one. So, are you guys seeing my screen?
Yes, sir.
Yep. Go ahead.
Okay, so I'm just gonna play the video out. It's only 1:54. You guys should be able to hear it.
Always short and sweet. WPG at Light Infantry.
That's another one I want to do. Is this bitoroidal transformer?
Mike, you gotta let the video. Do you want to restart it, Gerald? It's pretty
Vortex coil.
light sound.
It's a 1-inch coil.
Sure.
Check this out.
Turn it up.
This is my version of the Thane Hein system. See that right there? That's my little Vortex coil.
I'm at max.
It's a 1-inch coil. And as you can see, I have a pickup coil here. And I have one over here. This pickup coil, this meter, this pickup coil, this meter. And that pickup coil is that meter. We have nothing for milligauss in the background. That's our watt meter at the current time. And that is our frequency and our duty cycle on a square wave. So watch this, everybody. I'm going to turn this on. Watch these meters. Oh, what I'm using for power output, 12-volt wall plug, 2.5 amps. But it ain't using that. So check this out. In 3, 2, 1.
Oh, Gerald, can you mute your mic and it'll get rid of the echo?
34.5.
Okay.
30.9. That's our milligauss. Still at 0 watts. And that's our frequency. Dane Hine figured something out, that's for sure. Next, what we're going to see is, I know it's been a while since I've posted videos, but the future is coming.
How do you get more
Nice.
volts without watts?
Yeah, so
You
that's a
need to
little,
convert amps to watts.
little quick video. That's that 1-inch coil that I brought up before, and it's literally based on sacred geometry, and it's like 21 feet in either direction by filer, and that's it. And it's running what you see. But we have to throw a load on it and see what I'm going to pull out of it, and then see what the efficiency is from there. But so far, it does look promising. I mean, there's nothing on there for a Vortex coil producing 30 volts and higher. So it's an interesting experiment.
You're feeding it 12 and you're getting 30, but you're not using any more amps to do that. That's interesting.
Oh yeah.
Yeah, I'm getting 30 times
Yeah.
3.
That's pretty
That
awesome.
seems to be the trend with Vortex coils, huh?
If you can drop your volts on that coil on the other end.
Yeah, Vortex coils are amazing. I built over 175 separate coils, and not all of them worked, but I mean, I've showed that I've had maybe 45 on video. So
Right.
I want to show the rest, but I had to throw out a few because, I mean, not
And
all
for
of them
people
work.
who don't know, Vortex coils have many different designs, especially Vortex math. They're fractals, so at different scales, it can look like different different patterns. So that's why you have different designs for the rodent coil.
Yeah, I've made rodent coils. I've made the PoE. I've made Starship coils. I've made what's it called? The Holy Cup coil. I've made. I could show you pictures. I got into it heavily for a few years, and then this one came about. There's a story to it we won't get into, but yeah, just craziness now. And once you find that geometry, wow, the things you could do is insane. So
yeah, it's really incredible.
It's breakthrough.
yeah, when I do my
science.
APEC presentation, I'm gonna elaborate a lot more as to how it's done and how it works. There's more science to it, but I like to keep it simple. I like to keep it into layman's terms. Like I said, I'm a backyard wrench guy. Like, you know what I mean? I
Gerald,
love
when you're
to
ready to
build
wire it up,
things.
put it, make a schematic for you if you want.
Well, you want to hear a funny story? That big coil that you see that I
I'm doing my
had
best.
all the
Doing my best.
equipment
Try to draw
coils
it
on.
out for you.
Well, check this out. You want to talk shadow band? My first channel was called The Wisdom Walker. I put out a 7-video tutorial. Each video was an hour long, 45 minutes to an hour long, and it taught you how to make that coil in detail. There was a camera above it, and it showed me winding it. Then my channel got taken down. A week later, it got put back up. The 7-video tutorial was gone, and there's only one video on it, and I can't access.
This was on YouTube?
The channel itself. Yep, it's on YouTube. You can
So
still
what
see my
happened? You just
original.
woke up one day and you didn't have access to it, or the videos were deleted?
Yeah, well, no, I was locked out from it, and I couldn't get into it for a whole week. And at the end of the week, I could watch my video, but the other 7 were gone. They weren't even on the channel.
Did they give you a reason or?
Nope, nothing at all. And I asked, and they said we don't understand how that worked. So I mean, I don't know. Maybe it's
I-
because I had something that they wanted to see, and they didn't want the rest of the world to see it. I'm not sure.
I think
Yeah.
that when they transferred your ID on YouTube to another server, that conversion, sometimes the videos that you use different parameters, if they don't have it on the new server, a lot of things will drop out.
Oh no! His were like
Maybe, but
extremely short, small, and like I witnessed of everything. Both me and Jeremiah witnessed everything Gerald's talking about happening or happened to him in real time when we first connected to him, and it's ridiculous. His channel was by far the most shadow banned I've ever seen it happen to. He'd post videos, and when you load, you can't search his name. You'd have to like enter it in by hashtag just to get there. It won't let you find it. Then once you get there on the landing page, it says no videos. It won't show you any videos whatsoever. And then you have to like dig through, and then it gives you that one that it's all that's up. It's crazy.
Start using VPNs and change your name, Gerald.
I did that. You know what? It's funny. I can't even get emails back for Twitter, for Instagram, anything. I'm locked out from all social media. I can't get Discord.
Wow.
Nothing.
Oh, yeah.
It's absolutely insane. My first channel was hacked, and along with my first channel, my Facebook was hacked. So I haven't had Facebook in 3 years, and they just closed it because there's been no activity. And my first channel, it's still up, but I can't access it. So I mean, maybe I'm doing something right, maybe I'm not. I have no idea. I just I keep showing what I see, and that's it. What can I do, you know?
And you created
The more people we have recreating these things as possible, is the better, because they can, snuff one channel out, but they can't snuff like 100 channels at the same time. And then those channels are spreading the information to other people. We need to build a network of people who are trying to recreate these devices, and it can't be closed off, or it has to be all open source or as much as possible. And that's the way we bypass that suppression,
I think that might be part of my problem. I'm not a guy that's searching after money. I'm not searching after contracts or fame.
Right.
I just want to get it out, because you know what? I'm like one of those old school guys. It's like this. If my neighbors both have a snowblower, nobody's going to lose their snowblower to the neighborhood because everybody's got one. So if everybody's
that's a
got
good
an
point.
energy generator,
and
nobody's going to go around trying to steal them, or you know what I
That's
mean?
the same philosophy that I subscribe to.
Abundance.
The same philosophy I subscribe to. Like I'm not interested in making money off of anything. I just want to study it and open source the science so other people understand the science behind it. Because if it's not being taught, and it's just being kept secret for intellectual property, that's not only doing a detriment to society, that's criminal. That's not only unethical, that's criminal. And that's holding us back.
The way I see it, I mean, I'm not too old, but I'm getting there. The best time I could ever have with this whole free energy system thing, I'm not even sure if it's free energy. I wouldn't even call it that. I call it really efficient. You know what I mean?
It's just borrowed energy from the vacuum.
Just getting together with a group of like-minded people, smashing this out to make it work for everyone on a regular. That's my goal, man. That's just the cat's ass, if you ask me.
If you have a few minutes for me to demo the system, I'd like to.
Yeah,
but I don't know if you have time.
Yeah, let's end it with the demo for sure.
All right.
We always encourage real live science. Can't stop the progress.
Yes, Olia.
See if that's a good angle, so you can see both of the fans in the multimeters. I'm going to demonstrate the system outside of its resonance range and inside of its resonance range, and we'll see the difference between the powers and the input and the output. All right, so we're inputting 20 hertz square wave right now. You can't, but I know the camera is really weak. You can't really barely see it, but we got just a blinking light, just tiny bits of blinking lights. This one is obviously blinking a lot brighter on the input like it should be. Put the multimeters on real quick for you. All right, we got 1.7 AC volts, and you can see it's registering the correct hertz, 20 hertz. All right, and we got 0.42 on the output. Loss, like we should see, right? Now check this out. When I change the frequency to the range, because it's a range that you can tune into. It's you know, like not, you know, you're tuning up you're increasing the hertz, and then all of a sudden you hit it. No, it's kind of like subtle almost. But you increase to 1000 hertz, and you can see, look at this. 3.5, and I'll show you the current as well, because I can measure that now. This is spinning. This is not. We'll increase this a little bit. So this one has the capacity to work. It's the same exact components, same exact circuit, same 3 LEDs with a 2 ohm resistor, same 3 to 6 volt rated DC fan that comes with Arduino. Same exact on the input and the output. And we can kind of see, as I turn down the gain a little bit, because remember, it doesn't matter how much power we have driving the system. As long as we're in resonance, the geometry will take care of the rest. And I'll show you the current real quick. Okay, so we have 0.179 on the input amps. This one has a blown fuse, so I can't use that one for measuring current. .438 on the output. Can you see that? Just turn it off.
There you go.
Yeah.
There. 0.435. Well, what it's fluctuating a little bit, but 0.45 on the output amps. And we've seen the increase in voltage. Should I show you the input again? Because it looks like the backlight was interfering with your ability to see the actual number. .17 amps on the input. So the multimeters are clearly registering an increase on the output.
That's really
like
awesome.
I said, how much is debatable, but it is working as expected. And really, it's just about the resonance combined with the geometry. And what I think what we're doing is because when you think about magnets, I like to think about them as inflow and outflow. And when you create a monopole, I think you pinch off the inflow, and the outflow of radiant energy has no way to convert back into the ether.
Did you try hooking an analog ammeter in line to ground on the drain?
No, what you see is so far is what I've done with the system. Phase 2 will be a little bit more advanced. What right now I do have a battery adapter, and if one of you can draw me up a circuit and how I can make this work with just a 9-volt battery and a tone generator instead of using the stereo, that would be like the next phase of testing.
Can you scale it up?
So yes, but like I said, the stereo is limiting our power. So it's only 5-volt rated, and I don't know what the milliamps, but it's not a lot, and it'll shut down. And you can see, like, when I turn it up too much, before it hits the maximum gain, obviously, because if it's outputting more and coming back, more than expected, it shuts down quite a bit before you hit the maximum volume level on the gain.
Hey Ben,
So
if you drop me an email, because I put my email in the private chat there, I've got a modified Bedini circuit that's pretty neat, might work for you. So drop me an email and I'll draw it out for you, and I'll send it off to you.
Awesome. Yeah, no, I got a bunch of I got like 2 or 3 Arduino kits with a bunch of
Why
parts.
don't you just send flyback into the coil instead of
I'm sorry, come again?
Pulse the coil with DC.
Your mic is
your audio jack, Mike. It's so bad. It's like 80% static. It's kills or sauce.
But yeah, this is more of a proof of concept at the moment. But yeah, if we can apply this to something and take the test to next step and put it under a more bigger load, I'd like to see how it reacts under a proper load and see if it's actually usable for something. You know what I mean?
Exactly.
How about now?
Then sounds a little better.
Ben,
If anybody, I've open sourced this. If anybody goes to my channel, beneficencetv.com, and I put that in the comments. My latest video has the guide to make this. So far, and it's updated with some of my theories and techniques and stuff, how to make the coil and what's worked for me. So if you go to my page and the latest video in the description, you'll find a link to the rodent coil guide that I whipped up. And again, it's a work in progress, but if you have any questions, you can also reach out to me about trying to replicate
Check out a ZVS driver, volt switching driver.
That one, yes, 0-point energy.
No, ZVS, 0-volt switching circuit. It'll create flyback for you at a low amps, so you don't damage your coil.
I want to take the safety precautions so I don't damage any of the components, and that's something that I'm not.
There's no amps. It's all high voltage. You can't harm it.
But I'm not knowledgeable enough right now at this time, and I need help making a circuit that's actually going to work and not damage anything.
Hey,
Well,
Nathan,
you can buy a
really...
$10 frequency generator that'll do it for you. You can add any sound you want to from your amp into it, and it's only a 5-volt switch on it. So you can use your amplifier there, bring it into that little $10 module, and then you can also separate the power from it so it never overrides it. It's two little things on Amazon, $15, and you're done.
Yeah, if you could send me a link to one of those, I'll definitely order one and apply it to the setup.
Yeah, Nathan, Old Man Builds has a really good video on how to use a ZVS driver with high voltage. Go check out his channel. Yeah. He's got some really good tips for you on that.
It can't damage your coil. It's not with a ZVS.
So yeah, so far as I know, the only way to damage the coil, and this is from Daniel Nunez's research, is if you hook them up together directly. and they're both resonating. I think the resonance just is too much for the second coil. By the time the energy gets to it, it burns it out or so. It's kind of vague what he says, but it destroys the second coil.
Can you put the some sort of circuit in parallel or series or whatever way to scale it up?
I'm sure you can. I'm sure there's a way to scale this up because they had intention to. They wanted to build a house out of the Vortex design. So you live inside basically an energy field that would, be healthy for you at a specific frequency, and you wouldn't have any plugs in your home. Everything would just be wireless.
Yeah, that would be awesome. I mean,
you could feed the coil 12 volts from a battery with a relay. It's not going to harm the coil.
Right. So my idea at this point is to take a 9-volt battery, and this would, in my opinion, indefinitely prove that it's outputting more. Is take a 9-volt battery and measure the 9-volt battery on a circuit without the coil, and then measure it on a circuit with the coil and see if it's actually.
Yeah, but you don't want the 9 volt to be constant current. You want to switch it. You want to pulse it up.
But if I can convert the 9-volt battery, because it's doubling, it's a 1-to-2 ratio on the voltage while maintaining current. Well, actually, the current's actually increasing a little bit. So if I can convert or show that the battery is actually putting out more than 9 volts, wouldn't that indefinitely prove that the system is working?
Stepping up the voltage while dropping. That's Ohm's law.
Because a 9-volt battery is not supposed to put out more than 9 volts. But if the system is working like this on the 9-volt battery, we see a 1-to-2 ratio input output on the voltage. We should see an increase on the output side.
What I'm saying is the 9 volts is carrying, let's say, 10 milliamps to the coil, right? When the 9 volts gets the 10 milliamps through the coil converts the 10 milliamps to 5 milliamps and switches the volts from 9 volts to a higher voltage. That's how you Ohm's law it. It's conversion.
You cut out for a second.
Amps converts to volts. Volts converts to amps. There's no energy loss. There's conversion between volts and amps all day long. You have to sacrifice your voltage to get amps. Now we have 120 volts.
Mike,
right, we're talking about a standard system without the coil attached.
Basically,
you should see some kind of loss on the output side.
Well, to calculate loss is amps times volts. Once you know your resistance of the coil, you get your current, and that's your amps, and then you multiply that to get your watts.
Right now, the system is about 0.9 watts on the input and 1.4 watts on the output.
You got 9 volts on the input, you said?
No, 0.9 watts on the input and about 1.4. And this is the best finely tuned that I can get is around 800 hertz.
1.4 volts. Okay, so 1.4 volts.
No, 1.4 watts.
1.4 watts on the input? On the output?
Right. But this is with the this is with my 200 milliamp fuse multimeter, that blue. I have the same model, but it's rated 600 milliamp.
You get to 500.
And it's a little bit more accurate in picking up the current.
And use those. There's no way to blow those.
So what I actually am doing is ordering a bunch of backup fuses, because the current, since it's showing for the 200 milliamp fuse, it blew around over 300 milliamps. So I'm like, okay, there's, the multimeter was reading correctly, and it's reading, correctly outside the resonant range as well. But why did it blow at such a high, range for it if it's only rated for 200 milliamps? So I'm going to see what happens, and I'm going to get a bunch of backup fuses and see what happens on the input and the output, just increasing it.
And I'm saying you can get up to 10 amp. It's like $50 or something like that. Like a 5 amp.
Yeah, the problem with this, again, the problem with the stereo is when I plug it into the 10 amp on the multimeter, it shorts it out because the system can't handle 10 amps. I think it's maxed out at 5 amps or something. I don't know.
It's a digital meter, analog meter. It's a needle. The one with the needle moving left to right. That's an analog meter. Those are the best ones.
It's cutting out a little bit.
Mike, we can't hear you at all, man. You gotta. It's the audio jack cord from your headphones mic. Like,
I'm saying the multimeter, when I plug it into the 10 amp to measure the high, like the high amperage on the multimeter circuit, it shorts it out because the stereo can't handle that much. And I don't know if it's something to do with the circuitry or what, but the stereo is only rated for like 5 or something amps. So I can't,
that's not much.
Yeah, so it's kind of like limiting me in my testing right now. So I need to move the system outside of the stereo and get like a tone generator and a battery of some sort. And that's where I'm at right now.
You can generate a tone with an electromagnet and a DC pulse at any frequency you want, actually, with a function generator,
just a standard coil, huh?
Yeah, standard electromagnet, and you get to a certain frequency. If you have enough core material in there, or a type of iron core that vibrates better, it'll make a more pronounced tone that you can hear. But the output of the coil will also be creating the same frequency of the DC pulse frequency. Whatever DC pulse frequency you're giving the coil, the output of that coil, you can send it into your POE.
Right. Ideally, right now, I want to tune into around, if I can get it anywhere from 800 to 1 kilohertz, 800 hertz to 1 kilohertz.
You turn the DC pulse frequency up to that frequency on an electromagnet coil, and you can send it with a high voltage reverse channel diode using the flyback to get the signal into your POE, or you can just send it the forward direction into your POE. But there's going to be flyback regardless from the drive coil. The electromagnet is going to create a flyback signal in your circuit. It's going to hit your POE anyway, if I'm not mistaken.
Right, but the components that I have in the breadboard or whatever need to be protected.
Yeah, that flyback is hard to get around. When you're pulsing a coil,
I popped enough capacitors.
Is your adjustable power supply working that we saw in the video?
Yes, it is working. The workbench power supply.
Just get the $10 circuit. You're fine. You can use your phone as the generator.
So I did earlier because I just got the adapter to do so, but for my laptop to input a tone. So right now I was only limited to the phone and the stereo, but I have the adapter for the laptop, and I was just trying to whip up a circuit, but I couldn't get it running with the tone generator. So I don't know if I'm adding the tone generator and the battery correctly.
You're looking at high-low. You got to get the tone is on a very low. Your voltage is on a high. So it's a high-low circuit. So you have to run your voltage through this circuit that adds the frequency to it. It's like I said, it's a $10 device.
Oh, so the battery has to be running, and then
you mean a high pass filter and a low pass filter?
Yeah, it basically adds your frequency to.
So I can't just put them both on the. What I just is just put them both on the rail on the breadboard.
If you want to pass the high frequency to your coil without the low frequency,
so yeah, it didn't work. But
you can do that with a capacitor.
Okay. Oh, there we go. Series. There's one. Yeah. So when you can tune it in properly on the low end range, I'm assuming that's somewhere around 7 or 10 hertz. It also depends, I guess, on the size of the sphere. I think mine is a little bit too big for my coil.
Wow.
If I got a smaller one, I might be able to do that. Yeah, that's a neodymium magnet in there.
I like how it looks like an eye.
So what they're doing is just putting in a low end frequency. Like for me, it's like 7 hertz. And yeah.
Very stable.
All right,
it's nice how it stabilizes it.
It's pretty remarkable. I mean, it's mimicking a black hole, really, or a plasmoid, if you
or
will.
a magnetic bearing. It's like a magnetic bearing.
Yeah.
What's
All the same geometry.
the wrapped around? What is the material coils wrapped?
That kind of frame,
geopolymer, what's epoxy resin mix or something.
Mm-hmm. And that I have to emphasize, that kind of coil frame is not like, it looks good and it lasts. It's good for keeping up. But in reality, it's really hard to wind something like that compared to the method that I use in my guide, and that's something that Daniel Nunes emphasized. Is they tried everything. They tried even this method, and they found that the easiest method to do this is just to put it on the sliding disc frame and just use zip ties and tie it up like that, because this takes a long. Trust me, I tried it on my smaller one, and you have to like go through and glue it step by step and make sure everything is straight along the way.
Symmetric.
Yeah, and make sure the wires don't get bent while you put them back through it's a process, and there's some tips and tricks you can learn, but you'll definitely want to get some extra wire if you try one of these, because like I messed up a couple of them before I got it right.
Oh yeah. All right. Well, we are almost at 3 hours now. A full hour past what we want.
That's what you need.
Is everything you do open source?
Yes. You can get the guide on my channel.
The voltage goes through right here on this side. It just passes straight through. This adds you can just hook your phone right to it. It'll add the frequency to it.
Oh, okay.
Like I said, it's really cheap. You could do it anytime you want.
And what's it called again?
One here, my high voltage, to add a duty cycle and a frequency to it, so I can change the output of my high voltage coils. So that's a different one, but this is the one you want right here. It's real cheap. You can get a bag of them for like $10 at Amazon. Said the voltage goes straight through here, out the other side, and then your frequency goes in here. And it's 5 volts, so you can use your phone.
No, that's good. I'll look into that definitely, and I'll definitely need help constructing some kind of circuit for the next phase of testing. So I look forward to communicating with you guys via email and updating you next week.
Right on.
Awesome.
All right. So we got Tim. Tim, you still with us? Do you want to, if you're here, share your album of APAC Adventure? No. Did we lose Tim?
Tim the Body Ventura. No.
Right? Smackdown.
What Joe Man Randy said.
Mike is done.
From the WWF. Sorry, I had to.
Oh, good. Anyone, I guess, any other last words while we're waiting for Tim to get back?
Oh, I just wanted I put just a little comment in the private chat, but if you wanted access to the Rodent Coil guide, it's all open sourced on my channel. If you go to the video that I uploaded, I think it's the second last one, called 0 Point Energy Solved. In the description, there is the link to the guide on my Google Drive. So you'll have access to all that, and it's a work in progress.
As is all real science.
Yeah, so, but it will be updated. So if you check back periodically, but I do emphasize, try to, copy it and paste it somewhere, just in case, back it up for me.
You should try pulsing that coil with a double pull, double throw.
You're a friend of Ken Wheeler?
Yeah, no, I did. I actually have a video on Ken Wheeler. I love his work in magnetism, but I do a strong criticism of him on his economics. It's terrible. So if you go to my channel and view how capitalism suppresses free energy, that video delves into that.
Okay.
Actually, the United States has had a law since 1951 suppressing free energy because of the oil for dollar type situation that they had going on.
Yeah, the petrodollar.
Yeah, it's all interconnected. It's pretty amazing, actually.
Yeah.
Yep. Why they killed Stanley Myers.
Those bastards.
All right. Well, until Tim gets back, or if Tim doesn't get back, we can end it with this. But in lieu of Stanley Myers and trying to resurrect that technology, we need oh, come on. Where is it? Oh my god, did it closed?
You lost
What
your
the
cue,
fuck?
Bernie.
Lost it. All right. Well, I don't know. Now it's freezing. Doesn't want me to share the hydrogen video. Happens every time. Literally every time I share this hydrogen
I got a video on
fuel car video. It freezes.
on the pole flip demonstration of a coil.
Hey, Tim's back.
Yeah. Hey, I was going to ask Nathan,
There
have you tried experimenting with your mid plate on the Graviflyer? Jared and I have been talking about that a lot. Different mid plate experiments to try.
Like which one? Like for what? What kind of experiment?
That center plate.
Yeah.
I mean, I don't like. I'm just kind of guesstimating, but like, so he was talking about counter rotating eddy currents, right? And so then that brought me to this idea of torsion shear, which is something I've heard before. And if it's some kind of a torsion shear effect, like we talked about a bunch of different potential experiments, like maybe the idea, I think, was he was talking about counter rotating eddy currents in skin effect layers, and you got a really thin plate there. So you basically you would have these eddy currents that are like just like a millimeter or less apart, going in different directions in this plate. And maybe that's what's causing the lift, if it's some kind of a torsion effect. So if that's the case, one of the things that I'd wondered about was maybe like, what if you could improve the conductivity of it by trying copper mid plate, or maybe try one of the things I wondered was maybe putting copper tape over it, and basically you would have a junction between the aluminum and the copper, and you could get those currents even closer together and try and isolate them more. I mean, that I don't know. And then some of the other stuff we talked about was, let me see, he's going to coat, I think, his screws on the bottom of the rotor so they can bump the voltage up a little bit higher. And then he's trying magnets on the top rotor as well as the bottom.
I tried both, the top and bottom.
Yeah.
I've used nylon bolts. And I could tell you right now, you don't need to bump that energy up. And the actual eddy current works against you because you're taking it out of the right octave in the center plate. As soon as you add the magnets on top, that's why Alexi couldn't do it. It's the eddy current that actually couples the capacitor between the bottom plate and top plate. As Gerald always tells you, that you feel the eddy current in it, right?
Yeah.
But what he's not putting together is it's creating the capacitor, making your center plate able to grab a volume of energy to build up both energies on the top and bottom plate. So I don't think he's had the plate where you've had the voltage on the top plate. It'll expand by double no matter what you do if you can bring up your volume of energy in your center plate.
Okay.
And I don't know that he spiked it the way I did. I've gotten that thing to double and hit a second resonance state in this thing and just amplify like crazy. And the only problem I had was I bent my high voltage thing going in, so it sparked over and it was taken away from my energy every time it did. So I corrected that, and the thing it was lighting up with
Good
energy.
observation.
So you didn't see any lift effects from it, right?
No, not yet.
Let me see. Have you tried balance beam? You probably have, right?
Oh, you're talking about where he has it on the level?
Yeah. Well, that was my
Have
idea.
you tried weighing it at all? Maybe putting it on a scale. Maybe it is getting something. You just can't notice
That was
it.
why. Yeah. So what we tried was He had that balance beam that was like, I don't know, $10 from Home Depot or something. And so what we did was we created a balance. We just put string in the center of it, and then he put the graviflyer on one side, and he used a bucket full of water on the other, and he was pouring water in to match the weight, right? So so he felt like, I mean, it does have a fair amount of vibration, but he felt like it was actually creating a little bit of lift every now and then. So
also maybe it was like pulsing.
Yeah, he's using the flutter. That's what he's looking for. He's looking for flutter on his dish.
So
and it's creating a little bit of enlightenment.
Fascinating. That's
it might be it might be interesting to try and do a balance beam, Nathan. You might be getting some thrust with it that you're just not seeing.
Yeah.
Yeah, I think honestly, I'm hitting more of an energy level with it on the ground because of the way the Tesla coil is. So when I'm done with that, and if it doesn't work, then I'll do the balance beam as well.
Yeah. Well, and that was something he didn't try. He's got his suspended in the air. I guess he was saying he used to do it on the ground, but he's got it suspended in the air now. So
it has to do with the charge level. You got if you think of gravity like snow, right? And snow comes down. If you want to break that snow, you got to resonate this thing. So you got to vibrate it pretty hard, right? And the more you do it, the less the snow can stick on it. So it's the same way as gravitational waves. If you could break that with resonance, you're going to make it feel lighter to the environment. It will not change the weight at all. It'll just change the way the gravity affects it. And if you can do that, then you're good. That's why hitting the right octave with the right resonance and the vibration will actually break it free from gravity. It's why bridges go torqued out of condition when you do that, when too many people go over it and you keep the constant signal going with their footsteps or horses on a bridge. Everything like that disrupts the gravitational wave. That's exactly what you got to hit here, but you got to hit it dead on. And that's why I say the application of energy, because I can't measure it with my oscilloscope. I break it.
Yeah.
You know what I mean?
Yeah.
So I have to see it another way. And the only way Alexi sees it was when that energy picks up when it's ready to lift off. So I hit that state.
Yeah, we had a lot of EMPs when I was over there.
Well, you should see the ones that go off in my garage.
Yeah. Now some of those, there might be a way to isolate some of those. Some of those that look like basically you had high voltage that was dumping into the ground. And when I was working with lifters, we had that problem too. The problem is when your HV goes into the ground, it comes back up into your circuit through the ground.
Well, that's okay. Imagine that effect and suck into the ground, right?
Yeah.
If you can take all of that energy that goes to the ground and flip it in an instant, that's your lift. You have to take everybody keeps saying you can't get the energy from the ground. But if you're taking the ton of it and you're creating that charge just like your lifter does to the ground, where it sucks real hard to the ground, and then you get a pole flip. So you're changing the charge automatically from one to the next. It bumps and you raise.
Stubblefield, the Tesla's apprentice or predecessor, I guess. He had a battery that it was called the Earth battery. You just plug it into the ground, no input.
That pulled from the ionosphere, right? That was the ionosphere.
I believe so. Yeah, I have it in the Practical Guide to Free Energy Devices. I just haven't gone over it yet.
Yeah, I think that would be different than what we're looking at here. I know what you're talking. You know what? If you're interested in that Stubblefield thing, oh God, where is it? I saw a video online. You can actually build one with LEDs. They're low enough power
Really?
it's God, where did I see this? This was like probably a couple of years ago. They used a 6-foot LED pole, and they used a 6-foot pole and it had an LED in it, and there was like a little resistor or something. There was a easy circuit. You plug it into the ground, and the potential difference is high enough that it'll actually light up the LED, and you could use it as night lights.
That would be interesting to hook up in with the rodent coil to see if it amplifies it at all too.
I built a rodent coil. I never saw anything, but could be.
How did you have it hooked up, and how did you wind it?
Oh, it was a long time ago. I was running AC through it. I just used the standard rodent winding.
But did you bundle your wires, or did you use a loose wind method where you just loosely wind them on top of each other?
Loose bound.
Okay, so that is a common mistake with the rodent coil. What you want to do is actually take an electric screwdriver, and this is covered in the guide. You take electric screwdriver, and when you based on the number of winds you want, you tighten it real tight, and then you use the electric screwdriver to bundle the wires so they're as tight and evenly together.
I mean,
as
mine were tight for hand wound, but so what kind of effects are you seeing from it?
So apparently, when the difference is, I guess, what you're doing is when you leave in space for the wires, you're not compressing the magnetic fields and amplifying their effect, right? They're just loosely or not. So they need to be twisted and tightly packed together. So the effects amplify and compact on each other. So what you're doing is creating, like one magnetic field with one wind and another one with another wind and another one, and they're all compacting and compressing on one another. And when they're tightly compact like that, I believe that you kind of pinch off one of the poles at a specific frequency range, when you tune it in and using the geometry. And in my opinion, you pinch off the inflow to the aether, because magnets are nature's over unity devices. In my opinion, they take in from one pressure differential to the other, the North Pole to the South Pole. And if you look at my video, magnets can best be described by fluid dynamics. Why do opposites attract? It's the current of the aether flowing around them. If you take two spheres and spin them in a pool of water, spin them in the same direction, they're not going to spin the same current in the same direction. So they're going to repel.
So what you're kind of talking about, this goes to the same idea of the torsion shear effect.
Right.
Similar.
Yes.
So, but what kind of effects do you see when you do the coil?
So in the low end, you can produce a strong electromagnetic field with very low power input. And at the higher end, and I believe there's maybe like a harmonic where you can even go one higher, like megahertz range, and have another effect up there in that range. But in the higher end, you see over unity. And in my coil, it seems to have a 1-to-2 ratio in voltage while at least maintaining the current. So that means you'll have like 3.5 on the input on volts, and then you'll have like 7 on the output.
Interesting.
Yeah, it's fascinating. And there's a couple of common mistakes that people do with the rodent coil wind. And I believe if we can just correct those mistakes, people can actually replicate this.
Yeah, that's awesome, man. That's awesome. Yeah, well, what you were talking about with the vortex flows, that was I was looking at something kind of similar with the graviflyer, and that's kind of a different approach than Nathan is using conceptually, but
right,
it doesn't mean I'm right. I'm just kind of guessing.
Yeah, we're all just kind of like shooting in the dark here, aren't we?
Yeah, well, that's the problem, right? I mean, that's the problem. But maybe
this is the most. Oh, I'm sorry. I didn't mean to interrupt you.
Well, maybe that's good, though. I mean, you got like a bunch of different people who are approaching the same problems with a ton of different directions. Maybe that's good because everybody's trying different stuff,
Yeah, no, that is. And we're all out of the box thinkers, and that's important. But that I wanted to say just real quick that last coil that we saw, that was the advanced 432 3.0 coil, the last version, the most advanced version that the First Stop Energies Daniel Nunes produced. And supposedly that design will eliminate the ozone problem that the coil has at higher voltage.
That's the coil there. That's beautiful.
Yeah, they really had some beautiful coils. They spent 10, 11 years, their family making these coils, putting a lot of love and a lot of, labor into them.
I was in talks with them. They came on
That'd be
to a
awesome
live
on
stream
top of a
with
Christmas tree.
me and Alien Scientist one time, and then all
Really?
of a sudden, just like I was planning a full episode with them. It was supposed to happen in like a week's time, and like then all of a sudden, just every video on their channel disappeared. And haven't been able to heard from them since.
When was that? Like around 2022?
It was 2022, 2 years ago. Yeah.
Yeah.
Sometimes people get crank troll comments and it freaks them out. that UAP theory guy, Thor, he did that. He was just like, he I guess he got some troll comments and it just made him nervous. And he's like, I just don't want to have it online anymore. He took everything down. And,
Yeah.
So
yeah, and there's and honestly, the Occam's razor tells me the simplest thing that happened to them is they got sued or they got entangled in some kind of legal situation and got a gag order put on them. They just had to take their shit down off of YouTube or something.
Could be, yeah.
Very true.
Yeah, it's a shame. It's a shame,
It might have been they're growing vegetables in the dark, and the vegetables grew to the coils that got them maybe classed as national security and everything.
The agriculture industry is a mafia, dude.
Or maybe they weren't growing vegetables. Maybe they're growing something else.
It's not just the food industry; it's the medical industry, it's the energy industry. They're all just separate mafia.
Right. But the cat's out of the bag now, so it's up to them and their industries to adapt and change or die. That the cat's out of the bag. They can't put it back in the bag now. There's too many people on this. There's too many eyes, and it's we got the thunderstorm generator being demoed off this weekend in a what is it, North Carolina?
Could be.
Yeah, forgive me.
Yeah, the Cosmic Summit, I believe, is in North Carolina. Is being demoed this weekend. There's too many people onto this now. Joe Rogan and a couple of other major celebrity podcasters have already talked about this and had Randall Carlson on talking about Malcolm Bendel and his new technology. And that's kind of like the stepping stone into the next industrial revolution, where we kind of can introduce these new energy saving devices without disrupting the status quo. Have these industries adapt and change or die. It's just that simple.
Forgive me for not being too optimistic. I was around in the 2008 kind of rush into YouTube with all the different free energy and Bedini and Thomas Bearden, which I got to ask them both a question. And there was a lot of people working on free energy at that point. And there were a lot of different devices that looked very promising. And then nothing. It just all ended.
Well, and there's
it seems to be an unfortunate pattern. But I mean, I think the major mistake again is these people didn't open source their stuff. They didn't have backups. They didn't have apprentices.
I agree.
I'm gonna have to.
If I had somebody building a coil right
what
now,
I saw happen was several of them that were all open sourcing, and they were developing to the point where it was like, okay, this is clearly undeniable. Now we've seen that this actually is at the point and now crossed over and is working, and then boom, all of their channels just disappeared. The ones that actually had them, all of them disappeared. And then what happened next was the same models of those. Suddenly a few of these bigger debunking free energy channels all produced
an influx of them came
models
up.
Of each of them.
Let me ask you something. Was it just YouTube, or did they have backup channels on Rumble and stuff?
I don't think Rumble was around then.
No, it was
right.
So
what I think, and this is a good practice in general, is just to have a backup channel on Rumble, on different various platforms, just to back up your stuff as on many different platforms as possible. Because it's not like these if somebody is doing this maliciously, it's not like they have universal access. They probably have to go through channels to get through one platform to the next. So it's not, I don't think they shut down everything all at once.
The United States has laws preventing free energy from being released.
Right, but you have to understand these platforms are intellectual property themselves.
Oh no,
right?
I understand completely, but these platforms aren't exactly free entirely.
No, they're not exactly free. And there
have been a lot of scams. There have been a lot of scams.
Well, there's definitely been a ridiculous.
That's kind of why I built my forum. That's Wix. It's actually hosted and admin by me. I upload videos on there. If Wix wants to shut me down, then I'll just move to another platform. But if everybody just has the mentality of trying to use multiple.
Don't get me wrong.
Backups.
I'm right there with you. I want everybody to try this. I want everybody to build one. I want the whole world to have this for free. And if these platforms are the way to do it, then by all means, let's do it.
It might not be though. Well, no, that's what I'm saying. It might not be. We might have to build our own platform, and I'm not sure how to do that yet. But like I guess the forum on my page is kind of like a starting point, but still, it's not foolproof. But I think we do have to build our own platform. Screw these bigger companies. We can do it ourselves. Networking, grassroots.
It's called APEC, and here is the platform.
You have something,
and everybody needs to come to it.
Hey everybody, Tim Ventura here, and I want to urge you to visit altpropulsion.com and register for APEC, the Alt Propulsion Conference. Over the last 2 years, we featured over 100 of the top PhD physicists, engineers, and innovators in breakthrough and emerging propulsion, and we're looking to grow the conference this year even more. APEC is a Zoom-based online conference event. It's always free and open to everyone. We've been featured in Popular Mechanics, The Debrief, and a number of other media publications. This year, we're going to take things to the next level with
Right, so APEC is the platform, and there's the APEC Discord and Telegram, and what else is there too? Because that's where everyone's collecting, right?
Yeah, so those headphones I know when I recorded that, because I bought those headphones right at the same time that I bought the mic, and then somebody said, "Tim, quit using the headphones, use the earpods." So I switched to AirPods. So I'm
That's why you don't have the sound like Mikey does. Just kidding.
Right.
Well, this room I recorded.
I'm on a
that in this
Bluetooth
room.
headphone set.
This room.
Yeah,
echoes
now you're
really
good.
bad.
Now you're good.
So I'm
It's
still
very
using
short
a headset
range.
in here, but yeah. So APAC is on you. We broadcast on YouTube, but that's the conference. So the platform is YouTube, right? It's just the APAC thing.
Well, I get APEC needs an app, I guess.
I don't know. Do you guys? Did you see my? Can I show you my photos?
Yes, please do, and we'll
Okay.
probably end it off with that because we get. Well,
Yeah, I'm going to be doing some video editing tonight too. So, okay, here. I'll share that. Let me share this real quick. Oops. I'll be quick. So I have been, if you guys can see this, is that working? No. Oh, okay. There we go. I have been crisscrossing the country to take photos. These are all new, everything from Asilomar. So I went to Jared Yates. I've got videos of this on the Alt Propulsion channel also. And then these are all photos that I took at that time. And so this is Jared's Graviflyer. And let me see, let me go back up here. So the most recent one that I went to was, I just got back from the SCU conference, right? And that's the UAP one. That was in Huntsville, which was not the easiest flight. And so there's Matthew Sadagas, there is Kevin Newth, Gary Voorhees. I didn't label all of these, but I labeled enough so that you know who's who. And what I'm trying to do is basically just open this up and get higher quality photos out there. And so I'm trying to take advantage of all of these different events. There's Isaiah Ritchie, because Isaiah lives kind of near Jared. So when I went to visit Jared, we went over to Isaiah's place. And so that's his SEG. So I got photos and video of that, and I've got those up in the Alt Propulsion channel. And so the idea was, again, it's like well, you guys know, right? It's like we deal with so many crummy photos and bad video online that, after a while, it's just like, okay, somebody needs to put up
high
good stuff.
def, undeniable, non-AI documented work possible.
Because all the people working on these things, they're not, or a lot of them, they're not classically trained to they're not classically trained to
You
believe
need to draw
like
out your
this
diagrams
is
more often.
Well, it's just, I mean,
every time you change something, you should draw it out.
I get it. It's just these folks they're busy working on stuff, and so they don't invest the time. And I get that, but like my hope was like, maybe I can help just open this up, right? I mean,
right.
and then part of it, like with the alt propulsion channel, and you've probably seen that, the alt propulsion YouTube channel. I spent a couple of days at Jared's place, and I just tried to film everything, you know, because like if Jared or Nathan explains what they're doing with the Graviflyer, and Jared was using a lot of your videos, Nathan. He
Was he really?
Yeah, he was like, yeah, look at this, look at this, look at this. Yeah. So like the thing is, the work that you do, like other people use that to build off of. And so then it's like, man, if I can help share that, that's really cool, you know?
Exactly. Exactly. We're all here building off of each other's work to help each other paint a bigger picture.
Yeah.
Right?
So
it's a lot easier to do with diagrams.
So next week, I'm going to Drew Arigma. I'm going down to Florida, and I'm going to meet with Drew, and I'm going to try and just get a little bit more and try and present it a little bit better. And then after that, I'm going up to Mark Sokol's lab in New Jersey and just try and get what I can do there. So
yeah, that's cool.
Yeah, I mean there's no, unfortunately.
And then you got to go to Hutchinson's again.
He is down. Where is he at? He is down. It's north of San Francisco. It's like an hour and a half north of San Francisco. It's like an airport dead spot. Like you literally have to drive for like 2 hours, no matter where you fly into.
I would love to do an interview with him. He is so cool.
Yeah, I don't think he's I don't think he's actively doing work right now.
Yeah, he just wants to be left alone. I'm sure.
Some of this is old. Like that was 2005, right? So.
And why hasn't it progressed in 20 years?
You know what? I think EVs
Not
kind of
blaming you,
displaced a lot of this stuff.
Yeah, that was like a total cop out.
You know, like this was kind of moving forward and picking up steam. I think, and these guys are still around. I mean, you know, and some of it, like those, I don't know. The Hutchison effect, those are good photos.
Oh, yeah. Look at that. You documented scientific history evidence right here. With
those are some wild photos.
Where did you get these photos?
Tim took
I shot those at Hutchison's place in like 2005, 2006.
It just literally like melts apart.
Yeah, and so one of the things I noticed going through the videos also was not all the time, but most of the time when it starts to melt like jelly like that, it starts in the center. So it's almost like that's where the wavelength reinforces.
Right. Where it propagates.
Yeah, like it starts in this, he'll have like a big bar and it'll start to pull apart in the center of the bar.
Yeah, and no, I seen that in the videos. Yeah, like in strands.
And
almost.
that one too, right? That's one bar and it's started in the center. So
it's not supposed to be hot. Is that true? Or am I misremembering?
Yeah, no. I mean, there's one where there's a Canadian penny. If you scroll up, it's way up there. There's a piece of aluminum with wood in it, and it's honest to God, like it's right there. It's right there.
I seen that. I seen that. That was
that's from fingernail. That's from my.
So what is he doing? He's taking ultra high frequencies and different tones in multiple tones.
I mean, I have kind of a pet theory about what might be going on, but I'm not sure.
Well, and him and Nancy and APEC, when asking them specifically, it was very similar actually to what Nathan's talking about with the pop, and that like he's listening and gets these Nancy described them before, John, as like pop moments or something when he was in the zone or like the right frequency range to do it or something like that.
So what I could tell you is, any metal, right? You've got these little crystal domains in it. Those are visibly disrupted in these samples, and you can kind of see that on camera. But when you hold them up close, you can see that the crystal domains in that aluminum are seriously messed up. I mean, it's
crystals are switches. They're all facing the same direction.
So
if you polarize any of them the other direction, it's going to fracture the whole thing.
What I think may be going on is, okay, in any chemical, right? Like in metal or anything else, valence electrons hold it together, right? So those all have different frequencies, but like especially in a big sample like aluminum, right? You're going to have similar frequencies. What if you could disrupt? I don't know how many it would take. What if you could disrupt the orbitals for some of those valence electrons? You'd change the chemistry, right? But only when the field was on. And so maybe that's what makes it flow like a liquid, is he's hitting those valence electrons with, and then the minute you turn the field off, they kind of go back to normal, and there's no evidence that it ever did that. So you'd get like melting at room temperature.
That's interesting.
Isn't he putting in two different frequencies, like one vertical, one horizontal?
That's what I thought. I thought he had two different inputs.
He had lots of, so he had high voltage DC.
Some or more.
He had a
signal generator with a
Tesla coil,
antenna.
Sometimes multiple Tesla coils. He had a lot of stuff going on. He also had some old Navy equipment that he played with, and from what I understand,
from a submarine.
He would use different stuff at different times.
The kind of stuff you really got to have courage to mess around with.
Yeah.
Yeah.
He was definitely
and you got to be real safe with it and know what you're doing.
His neighbors hated him.
Yeah.
So
I'm sure he caused all sorts of brownouts all the time.
Yeah, that one is so there's brass. There's aluminum bar, right, and then there's brass. The brass is kind of the yellow one. There's no evidence of heating or tool work on any of
But
these.
look at the brass; it's like bubbly almost, like it's spherical patterns.
Yeah, and then above that there was iron, and with the iron that was actually hardened, or what was it like?
This
it was from
like
an axle,
kind of bismuty, like crystal formation, but it's brass. I get it.
He was pumping up the amps with a clean signal.
That's part of an axle, right above it. Right above it is part of an axle, and.
Yeah.
To me, that almost looks like erosion. I'm not sure if that's Hutchison effect. That to me, that kind of looked like erosion. Right to the left of that, that's aluminum, and I was trying to get a close up of the crystal domains, right? And you can kind of see. I mean, that's a bar of aluminum.
Chalky, salty kind of.
Yeah, something just trashed it. I mean,
compared to this, it almost looks like wood or like frozen clay or something, right? Like,
yeah, but I mean, I've held those, and it's aluminum. So whatever happened to it, like, and then that's a steel table knife that's embedded in a block of aluminum, and that happened at room temperature, and then they put it in I don't know, some kind of a vice grinder to cut through it so you could see it, but it went right in. So. And you can see there's no evidence of heating or anything like that.
Yeah, you would see it if it was melted. You would see it.
Yeah,
it looks like it's just fused together.
Yeah.
If you can get your signal up with enough amps behind it without any distortion and a nice clean signal, and whatever material that signal passes through is going to try to shape itself to the shape of that signal. Assuming you got enough amps behind that signal.
He wasn't using amps though. He was using all kinds.
Yeah, he had some high-powered frequency generators. You kidding me?
John.
High power. He was very courageous.
No, Mike's right. John did some crazy shit.
I know what he was. I saw his equipment. I was following it.
Right, like sonars, radars, all sorts of crazy. Like literally, he was stripping.
He had old school Navy equipment. That stuff's high amp, Gerald.
Yeah,
I know he had a Klystron at one point.
but that being said, most of these effects, I think,
vacuum tubes,
Tesla coil created. I think, Mike, I think he added most of that stuff later, and I don't think that created most of these effects. I think most of this is like multiple Tesla coils and Van de Graafs. But then the other thing that you got to keep in mind is he worked in a really, like, it was a tight space lab, and there were lots of resonance effects, right, from tables and racks and shit like that. So,
hey Tim, was Jared getting cold heat on the center plate? So the plate would be cold, and then it would have tremendous heat where you burn your hand.
I don't think so.
I get that in mind.
Yeah,
It'll be
and you were
74
saying that
degrees.
the cold's on the inside, Nathan, and the heat's on the outside.
Nathan, you sure it's
correct?
not a cold burn? Because you can be burned by extreme cold as well.
Well, all I know is my finger was absolutely
Liquid
burnt
nitrogen,
in
yeah.
seconds.
Do you think that might be from the voltage, though?
There's nitrogen in the air. Maybe the
wasn't from the
plate was
voltage at
grabbing
all.
onto nitrogen.
It didn't happen until you hit a special resonance state. You don't get it right away.
Nathan, if you can take some videos of specifically that phenomenon would be awesome. Because
I'll burn my finger for science for you.
Yeah.
No, I will. I'll do it.
I mean, the air is 20% nitrogen.
If I get to go back to Hutchison's, if I get the opportunity to go back there, I will try and get some more photos. I think he still has most of these samples.
I think it has to do with the vertical waves and the horizontal waves and their combination when they hit in the center. Because I'm getting that in the gravity flyer with the piezo disc coming down and then the rest of it coming across the center plate.
You might talk about that with Gerald and see. I mean, one of the things that just by visiting there and throwing ideas out, it had some inspiration. And you guys are both builders, so maybe you'd cross inspire each other. Just have a tuning session or something on Zoom and see what you can come up with.
Brainstorm. But I was skeptical of Hutchinson at the beginning, but when I think about it twice, I got an hypothesis. You remember the atomic forces I showed? I said that it's easy to change the parameters. So maybe that's what he's doing. He changed the atomic cohesion of the atoms.
Hutchinson has been suppressed relentlessly.
I kind of also suspect, as Bob Greenier is pointing out with ball lightning, the EVO, that there's some sort of plasma field is created from
Bernie, it's interesting that you mentioned that. So the EVO thing goes back to Ken Shoulders. That's who originated it. And Ken and John were close friends for years. They used to email each other. And John and both of them felt that too. They both really felt that EVOs played a role. They used to talk all the time, man.
Speaking from personal experience, when I first seen the Hutchinson effect and researched it the first time, I thought it was phony because the video I was watching debunking it was actually put out after his videos, and it was just one of his videos, and they edited it a line or they replicated it in some way to make it look fake. And
there was one that people got really pissed off about. He told me when he was going to do it.
I never saw that.
The thing to know about John was, number one, he changed his equipment several times. He would have equipment break or whatever, or sell it or whatever. The other part was he quit for several years because he was doing it all in an apartment, and his apartment landlord just said, "John, people are complaining," right?
Yeah.
So he got back into it.
He had amps.
He had TV crews come through, and one of them said, "What about this lifter thing?" And I was doing lifters at the time, and John said, "I'll do a lifter," and he put a toy UFO on a string, and it was a wire. And he just put a high voltage on it. You could see it move a little bit with the high voltage. And that got on the internet, and people said, "Oh, look, it's fake. You can see a string." Well, the thing is,
that's the video. Yep.
Okay, basically it was a TV studio that said, "Build a lifter for us," and then it got misinterpreted, I guess. But
so it was actually authentic footage, but it was
interpreted or misrepresented.
Right?
Yeah, he was just playing around, and he didn't even have his classic Hutchinson effect stuff at the time because he called me. I talked to him the day before or the day after he did that. He described the whole thing.
But that video has been used to debunk him for years, and when you look at it a second time, you're like, "Wait a second, how is he doing all this other stuff?"
No, it was totally different. It was totally different. He didn't even have the original equipment, and he wasn't turning on the stuff that he did. But part of it was
you can't find any of his original videos anymore. I mean, when he first came out, you could see them.
Putting them back up on his channel.
I have them. No, I have them.
Yeah, on his website, there's a lot of.
Tim has
you
them
can't
all.
find
There we
on,
go.
social media anyway.
They should be up on Alt Propulsion. That used to be the American Anti-Gravity site. There should be his original. So, okay, the original footage they did was Super 8 footage.
Like, find the one with the bowling ball, like right now. You won't find it that easy.
Let me see.
Tim's got it on VHS somewhere in the box. I guarantee.
I seen how was it a bowling ball? It was a steel ball or something, a cannonball from a cannon.
Yeah, it was
Yeah, I remember
freaking
the cannonball.
huge.
And
It
Yeah,
was
there we go.
huge.
Here we go. I'll put it right into chat.
Can you play it? Can you share screen? Play it?
I tried looking for that one.
Yeah, it's on. Yeah, this is everything, and then
He has a lot of stuff on his website too, but you have to pay I think it's like $34, and you get access to like a whole big archive. I mean, some
Oh,
of
I
it's
didn't know
not science stuff, but yeah.
Oh, I don't know. Yeah, I don't know about that.
It's like John Hutchinson or Hutchinson.com or something like that. I forget the domain, but I can look it up real quick.
Yeah, I seen all the when he first came out on YouTube. I saw the one with the bowling ball.
Yeah,
and
I
that
mean,
was like,
if you want,
I'm sorry, the cannonball. Yeah.
Sorry, I'm trying to load it. My computer's being slow and crappy.
The cannonball he had lifting for quite a while.
I can here if you want. I can. Bernie, do you want me to play it?
Yes, please.
Okay.
I think that's right about the time that they started censoring them. when he
I put a
released that
soundtrack
thing.
over this because it was kind of cool and creepy at the time, and I kind of regret it now. See, that was my.
Okay,
And
I'll put the link in there if anybody's interested.
Gravity.
I don't know.
AAG.
I have the law, yeah, because that was I have the raw video in here too, but yeah, what they did was they took the Super 8 and they cleaned it up because that was film footage. George Hathaway shot this, so part of it is like if you want to know. So this is some of it. This was like highlights from the Hutchison effect. And this was I think this was 1080.
Crazy. A plastic bottle.
Yeah,
Look,
there's
the
there's the
cannonball.
ball. Yeah.
Right, first the wrench, then the.
That cannonball weighs about 20 pounds.
And how the wrench went first, or the vice grips.
Is that a
the
bucket?
cannonball.
That's yeah, a 5-gallon bucket on the floor there.
That's a file, just so you know. That thing that's glowing and sparking is a file. It's like a steel file. But it wasn't hooked up to anything. It was just doing that spontaneously.
Did he ever make anything disappear completely?
He had said the short answer is yes. I think he had that happen once or twice. He also said once it happened and there was some kind of a big glow. There was like he also had some weird
So I have something to say about that. On his website, if you look on his website, his official website, it says that the military looked at his videos, the Canadian military or whatever, and they said to him, do you realize that in a couple of your videos for like a frame or two, things are disappearing? I couldn't see them, but that's what it says on his website.
And let me see if is this the one? No. What one's this? Yeah, this is the original. Okay. So this one is here. I'll drop that playlist.
What is that?
And look at the field
that is
line.
so that's water. It's a cup of water, and again, this was shot on Super 8. This is when it was not cleaned up. Yeah, it's so the the magnetic fields or whatever are vibrating the water. So that's what that one is, and then
like look at the field for.
Okay, that's the file. That's just a steel file. That's a steel file. You can see sparks coming off it. I think he had that pinned between two pieces of wood or something, but it wasn't connected to anything. There's sparks coming off it. You can see those.
He's like ionizing the air or something.
No, you could put a coil over it and energize the coil would heat up the iron.
This was a what was this? basically it was like a steel wedge, I believe. Sorry. Here, I'll just zip through some of these. This was a steel wedge that never flew entirely. So one end of it lifted up, but the other end was too heavy. So it's kind of vibrating on the table. And then that's another one. It's a steel wedge block of some kind. Same thing, where it can't quite get off the table. So it's got a little bit of weight still.
Kind of like these haunted houses with the chairs that are rocking on their own.
It's
There we
so
go.
wild, like how it's almost like it's pulsating, right?
Yeah.
Yeah.
And then you guys, the cannonball, he actually had, there's a lot there. You could see, I mean, that's like 10 minutes of it.
That's a
kind of
5-gallon bucket on the right there. You see that? It's the table sitting on the bucket.
Oh, yeah.
Give
Thanks, Mike.
You know what?
Give you an idea of how big that ball is of steel. That's probably 30 pounds, 40 pounds.
He had
are the ones that are not made of metal.
that is a cup. I think that's a cup with like milk or milkshake or Elmer's glue or something like that.
Yeah, it bubbled
So it's a
up and then
liquid.
shot up.
There, I think you can see it again. Yeah, what I'll do is in just a sec, I'll drop this playlist link into chat for you guys. And I think that's
so wild.
There's more liquids. So there's that one, and then the other one. Let me back out of this really quick, and I'll copy this playlist. Where is it? I think here it is. Okay. So this is George Hathaway. George shot, if I understand this correctly, George shot a lot of this video. And so there's George describing some of the things, right? Like he's like, okay, here's what it was. It's rocking back and forth or something like that. There's him. And then there was also at the same time, and this is 8 minutes long. And again, this footage sucks, but there's John describing what went on. And this is like early 1980s. So that's why his face looks all distorted. I think this was VHS footage. Okay, here, let me stop. I'll stop sharing. Oh, and here is...
I would argue that footage was epic, even though it's low quality.
Yeah, well, that's why I put it up. And the problem is that's all there is, right? So, you know.
This footage is some of the most legendary footage out there. Yeah.
Yeah, well, John sent me the highest quality he had, and then I took it. I think a lot of that I took off VHS.
If I had my workstation, up, I could try to upscale some of it, but my computer's down at the moment.
Yeah, you could. I would have to go through my hard drive. I think a lot of that I saved in Windows Media Format, because it was early 2000s and I didn't realize. I mean, back then it was like, yeah, this will last forever.
But I have so many boxes of DVDs. I really, really regret.
I'm on a Mac now. I can't even play Windows Media Format. It's like,
oh boy.
Yeah, so I had to figure something out. But
well, guys, this has been awesome, but I gotta bail.
Absolutely.
So.
Yeah, well, if you're interested in that, if you guys are interested in that Hutchison stuff, I just dropped the playlist in there. You know, I mean,
sure, yeah, thank you.
Thanks,
and I just shared it in the live chat for everyone.
I don't have live chat. All I have is the private chat.
No, on top there's a button that you hit on the right, and it'll show you the comments.
So.
Oh wait, never mind.
Oh.
Yeah.
Okay. All right, everyone. You guys have a good night. I'll email.
Gerald, we'll see you later.
Nathan and
Ben. Have a good one, guys.
Have a good night, everybody.
Yeah, have a good one.
Bye-bye.
Absolutely. When's the next APEC there, Tim, before you leave? Oh, Tim's already gone. All right. Well, in that case, thank you, everyone, for being here. Subscribe to Benefactor, Old Man Builds, Mike Does, Phil Bouchard, Faraday Research, WPG and Light for Truth 2, myself, and we'll be back next week. Thank you all. Ta-ta.
Thanks, guys.
Have a good evening.
You crazy mother. Yeah.
It's just burning.